Hi there, my name is Michael Moore, founder of Double M Development, and my goal is to make you the best game developer in the most fun way possible. The course you're about to watch right now is a course that I have on Udemy and Skillshare that has hundreds of super positive reviews, and today I'm going to give it to you for free. Well, not all of it, because I still have to pay my rent somehow.
Give me rent.
You'll get your rent when you fix this.
Anyway, you can support me by leaving a comment and hitting the like button somewhere down here. And if you got to the end of the course, or you are somewhere in the middle and you want to get the full 10-hour version, just scroll down to the description and I've left there links that you can use to get it either on Udemy or Skillshare, whichever you prefer. Of course, with a special coupon to save you a bit of money. I'll also leave a link to the Discord server that you can use to join our great and growing community, where you can share your game. If you have any questions, you can ask them, and you can help out by answering some questions there also. Finally, if for some reason the links in the descriptions don't work, you can contact me either on Discord or on Instagram or on LinkedIn, and I'll help you out. Now, let me give you a quick guide on how to watch the course and how to navigate through the long video. So, if you're a total beginner, I recommend that you start off at the very beginning from the first course, where we start with the very basic introduction and downloading Unity and all of that good stuff. And if you want to refresh your memory a bit, you already know your way around a bit, I recommend that you start at this time. It will be somewhere around me, and you can start from that video or that timestamp. It will immediately take you, you will not have to go through the downloading and all the small processes. You'll just start off where the course begins. And if you are already a seasoned Unity user and you just want to see how this course is made and what you can do, then I'll also leave a timestamp somewhere around here that you can use and just get into the nick of it. The video will be timestamped, so in here down below on the red bar, everything should be timestamped. If not, I will leave the timestamp in the description so you can go to any video that you like. I also use source tree, which is a very powerful tool. So I recommend that you watch the video or the little section, which should be around here, on the source tree. It's like maybe a 16-minute video. It's not necessary to complete the course, but it's a very powerful tool, and I do recommend that you check it. Also, I recommend that you watch the how to use this course, which will give you the basic ideas, because I have challenges and stuff. Anyways, good luck, and remember to have fun. See you in a minute. Welcome back, everyone. So in this video we are simply going to be downloading Unity Hub, installing our version of Unity, and setting up everything in order to start creating games. So let's get started. First thing you'll need to do is you need to go into whatever browser you're using. I'm currently using Google Chrome. It doesn't matter. Simply go ahead to Google and type in download Unity Hub, and you should get this search result. So simply go and click on the download Unity Hub. It should be the first link, which should be on the unity3d.com website. And it will take you to this page right here, and it will ask you to download Unity Hub. Now, what is Unity Hub? Well, Unity Hub is a place where we can add different versions of Unity, and we can also have all of our project represented very neatly and very carefully, which is very helpful and much better than the way we used Unity before that. So simply click on download Unity Hub, and you should get the installation, which is right here, which is Unity Hub Setup. So double click on that and it will start an installation. It's fairly easy. You simply click on agree and install it in wherever destination folder that you have. I already have Unity Hub, so I won't bore you with the download process. It will ask you to agree to something, which is fairly easy. So go ahead and install Unity Hub. Okay, so now that you have Unity Hub installed, you should get this window right here. And first thing you'll need to do, because I'm already signed in, so you'll need to create an account. I'm currently using my Google email, which is very helpful and much easier. And here you can see that we have all of our projects. Now currently we don't have any projects yet, but we will very soon. Here you have different tabs for learning and for the community, which you can go and check out and see what there is. But what we're going to focus on right now is going into installs. Now, as you can see, I already have a version of Unity, which is 2020.1.2 F1. So maybe you're from the future and you have a better version or a newer version, and in order to add a new version you simply click right here on the add. So when you click on add, it gives you different options to download Unity. Now as you can see, you have recommended releases, you have official releases, and you have pre-releases. Now what should you choose? Well, personally, I like to choose the official releases because they are usually the least buggy. There is the recommended release, which is also not bad, and there are the pre-releases. Now, pre-releases are not always that buggy, but sometimes you may encounter not very good performances during play or during game creation. They are not that common, but I personally prefer the official releases. So go ahead and choose one of them. Let's choose the official release of 2020.1.10F and let's click on next. Now this should take you to another modules to your installation window. And what we have here is a bunch of add-ons and uses for the Unity. So for example, you have Android build, which will help you build games for Android. You have Linux build support and Mac and so on and so forth. You also have the documentation, which I recommend you download, and you have the language pack, which if you have some kind of different language, Chinese or Korean, I'm not sure what those are, you can also check one of them and download that. But most importantly is you have to check this developer tool, which is Microsoft Visual Studio Community 2019. Maybe you have a newer version. So this is absolutely a must, because we will be using the Visual Studio to code all of our games. So go ahead, click on those and click on next, and the download should start right here. Well, you'll have a box similar to this one and with a little blue bar up here waiting to finish the download. So now I'm going to introduce you to your challenge, and this is your challenge for today. So you need to download Unity and Visual Studio. So first of all, go ahead and download Unity Hub. Then download Unity's latest release, and make sure you also download Visual Studio with Unity. So go ahead and do the challenge, and I'll see you in the next video. Welcome back, my favorite game developers. I've created this video in order to help you maximize your learning potential in this course. So let's talk about the few things that you'll need in order to do that. First thing, we have the Q&A. And what is the Q&A? Well, it's a place on Udemy where you can actually ask me any question that you stumble upon. So if you find yourself in a certain video and you're not able to complete the task at hand, or you're finding something very hard and you can't understand it, you always have the Q&A right here under each video. Here you can first of all search for your question. Maybe someone has already asked the question and you can find the answer right under there. And if you don't find the answer, you can always ask a new question. So first thing you'll need is the question title. Make sure it's very precise, and To make it easier on me and maybe other people in the community, make sure that you always add as much precision and make your question as clear as possible. So add code to it. Some people might use this code and to try it out in their own game and see what's wrong. You can add images of certain errors and make sure that you, for example, maybe make the important words italic. Make sure that your question is as concise and precise as possible. And finally, if you do find, or you can always go back and delete the question if you find the answer, or you can edit. And if you do edit your question, make sure to add the solved in the title. So if you find that your question has been solved and has been answered satisfactorily, make sure that you add in the question title these words right here, solved. And this will not only help me to know which questions still haven't been solved, it will also help other game developers just like you find the answers to their questions and find them solved in the Q&A. Great. Next thing, let's talk about the challenge slides. So you've already encountered your first challenge slide, and this is your challenge slide. So whenever you see this slide, you'll need to pause the video and do the challenge on it. It's a much better way to learn, and doing is always better than watching in my book. So whenever you see the challenge screen, know that it's a great opportunity to go out and try to tackle the task at hand. And the reason I created these challenges is for you to get as much benefit from this course as you possibly can. I've personally tried over 10 courses where the instructor simply goes through the motions, and at the end of the course I had created a game with the instructor, but I haven't learned anything, and I felt I would never be able to replicate any of it. The challenges give you the opportunity to try, make a mistake, and get stuck trying to solve the problem. And even if you can't figure it out, if you have no idea how to do the challenge, try. Even if you cannot complete the challenge, when I complete the challenge after you've tried, it will be ingrained in your brain. And next time you see the problem, you'll remember the mistakes you made and how not to do them again. Trust me, this is the best way to learn and will keep you active as we work through the game together. So, next thing I want to talk about is the course structure. So, the first section, which we are currently on, will be the introduction and the setup, where I will introduce you to Unity if you're new to it, and introduce you to the Visual Studio and why we'll use it. We'll actually also create our first code and our first script, which is very exciting. The second section will be the Magic Game Cube. Okay, so, and it's a cube that is in 2D, which makes it magic. And it basically will cover the C# and Unity basics. We'll talk about the basics of C# and the tools that we'll need for our coding later on, and the basics of Unity and everything that we'll need to understand, from collisions to rigid bodies to physics in Unity and so on and so forth. Now the third section is where things will get very interesting, and it's our project, which is Castle Conquest 2D. And in the section 3, we're going to be setting up our world. We're going to be creating our tile sets. We're going to be creating our world, adding collisions to that world, and adding our player. But not so fast, because in section 4, we're going to be adding our Conqueror. And we may introduce our Conqueror in the section 3, but in section 4 we're actually going to give him the abilities to jump, to run, to have different animation, and so on and so forth. Now in section 5 is where things get a bit scary, because we're adding enemies and bombs. So now our player is no longer safe. He will have to fight off enemies, and he will have to avoid bombs along the way as he tries to conquer the castle. And in section 6, we'll start controlling our game. So we'll be adding a score, we'll be adding lives, we'll be adding multiple levels to our game, and everything that goes on with it. Will actually also be adding a lot of sound effects and make our game much cooler. And finally, in section 7, we'll have the bonus section, and I've created this section. I actually added this section on because all the core game mechanics will be in the first 4th section, but the 7th, the last section or the bonus section, will be where we tweak things a bit and just for the fun of it make our game a bit more exciting and more fun. So make sure to always check out the resources that are next to each video if you find them. There I will be linking the documentations to Unity. I will be linking changes to our code and different things that may help you in the current video. And finally, as a final note, I just want to say that if you put the extra effort into this course, you will get out of it much more than you paid. And that really is my goal, is to leave you as an expert problem solver and a good game developer with lots of tricks up their sleeves and maybe even become a friend. So I'll see you in the next video. Okay, so welcome back to another video. Let's see, what is Unity? So Unity is a cross-platform game engine developed by Unity Technologies. We'll use Unity to develop our game. So what does cross-platform means? It means that we can use it on different platforms, and it's a game engine. And what game engine is, it's an environment for us to develop games and add physics and add different things to create our game. So let's check out what Unity actually looks like, and I'll explain a couple of things on it. So this is Unity. First of all, we have this toolbar right here up above everything, and this provides access to the most essential working features. On the left, it contains the basic tools for manipulating the scene view and the game object within it. In the center, we have the play, the pause, and the step control button, and the buttons on the right give you access to the Unity Collaborate, Unity Cloud Service, and Unity Account, and we'll not get much into that. On the right side of those, we have the layer visibility unit menu, and we have the editor, which provides some alternative layouts for the editor window and allows you to save your own custom layouts. So if you don't have the same layout as I do, you can simply click right here on layout and you can choose the default layout, and this is the default layout that we have. It's the projects right here and inspector and everything. Next thing, we'll talk about the hierarchy window right here. It's a hierarchical text representation of every game object in our scene. So each item in the scene has an entry in the hierarchy, so the two windows are inherently linked. The next hierarchy reveals the structure of how game objects attach to each other. So right here we have the sample scene, and if we click on that, we have the main camera under it. And if we add another game object, it will also show up right here. And here is the inspector, as you can see on the right. This is the window inspector, and it allows you to view and edit all the properties of the currently selected game object. So if we don't select the game object, we don't see anything. When we click on main camera, we have these different windows right here, and the layouts and contents of the inspector window change each time you select a different game object. So now we don't have a different game object, so we'll just settle for the camera. Next thing we have is this scene view right here, and the scene view allows you to visualize and navigate and edit your scene. The scene view can show you either a 3D perspective or a 2D perspective, depending on the type of project that you are using. So in this course, we'll be using the 2D project view, but you can also right here click on the 2D button and it will go 3D. So as you can see, we have this 3D view, but we won't be needing it. We'll simply go into the 2D mode. And finally, I want to talk about the project window right here, which displays your library and assets that are available to use in your project. So when you import assets into your project, they will appear right here. So for example, for now, we don't have any assets. We only have the scenes folder, and inside the scenes folder, we have this sample folder. So this is a quick overview of Unity and what all those panels and gadgets are. We will, of course, delve deeper into them as we go through the course. But now I want to talk about something very important, and that is the Visual Studio. So what is Visual Studio? Well, Visual Studio is a Microsoft Visual Studio. It's developed by Microsoft, and it's an IDE. An IDE is an integrated development environment, and what it does, it actually, VS meaning Visual Studio, will help us write the code used to manipulate game objects in the Unity using something called scripts. So how to use Unity with Visual Studio? So we need a way for Unity and Visual Studio to communicate, but they do not simply do that. We need to add something to it called the .cs file, and that is our scripts. And those scripts we actually take those scripts, we attach them to game objects, and using those scripts, we'll be able to add behavior to different kinds of game objects, and we'll see that very, very soon. So let's go into Visual Studio and see what it's all about. This is Visual Studio, and maybe the first time you open it up, you'll have different panels right here on the right and different windows right here on the left. Feel free to close all of them and don't worry about what happens next. Of course, you won't have this the first time you start up Visual Studio, but you'll see it soon enough, and I'll just introduce you to a couple of lines of codes right here. So let's zoom in just a bit. And right here on the top, you can see that we are using system collections, we are using system collections generic, and most importantly, we are using Unity Engine. Now, what are all of those? Well, those are called namespaces, and basically these are libraries that give us the opportunity to use different kinds of code. So for example, Unity Engine, which we've added right here, allows us to use the start method and the update method and different engines to create games and make it much easier. And we simply write here using Unity Engine, and it saves us a lot of code and gives us the entire library to use. Next thing, we have the public class name, and this is actually the class name, which should be right here. It will be the script that we've talked about, and it will be attached to a game object, and it will encompass all of the code that will change the behavior of our game object inside of our game. And mono behavior is a base class, and it's actually these two mean that it inherits from the mono behavior, which allows it to use different kinds of manipulations and engine and physics and so on and so forth. And next thing we have is the start, and above it is something called the comment. So whenever you write code and add these two lines right here, it will comment things out, and comments actually don't get executed in the code, and they are perfectly safe. So it's start is called before the first frame update. So as soon as our game starts, the start method, and this is called a method, will start to execute. Next thing, we have the update, and the update is called once per frame. So every frame that we have in our game, the update is called. So start is typically used to give the initial properties or configurations to certain objects, and the update is used for objects that maybe are moving or change every frame. So if we have a car, for example, in start, we can give it the color, the name, the speed at which it can go, and an update will be moving the car, will be making the car jump, will be making the car go faster, maybe increase its speed. So you get the basic idea of Visual Studio. And now it's time for your challenge, and your challenge is to go make a mess. So open Unity, create a project, and if you don't know how to create a project, we'll do that in the next video. And when you're finished, after you go make a mess, go to the next video and we'll make our first code and get started. So I'll see you in the next video. Welcome back, my fellow game developers. In this video we are going to be creating our first code and our first game object. So as you can see right here, we have a game object called hello world in our hierarchy. It's present right here in our scene, although we don't see it very well, and we have this script right here attached to it. We've also created the script right here in our project, and in console, if we click on play, we actually get a message that displays hello Michelle, which is me, but in your case it is going to be displaying your name. So I'm very excited for this video because it's our first delve into Unity world. So I hope you enjoyed the video and I'll see you in just a bit. Okay, so first thing we're going to do is we're going to open up Unity Hub, and currently you have no projects here, which will change in just a bit. First thing we'll do is click on new right here, and we'll need to choose a template for our game. So we'll be creating a 2D game, not a 3D, and these are different options also for different project types. Next thing, we'll need to add a project name. Feel free to name it whatever you want. We'll be calling it for now the Hello World project. And make sure that you choose a location for your Unity project. So we'll click on this one and let's go back and save it inside of the Unity projects. So select the folder and now we have a location for our game. All you need to do right now is click on create. So click on create and Unity will start to create your project, and I will not bore you with the waiting here. I'll use the magic of editing and we'll simply jump into the project. So see you in a bit. Welcome back. So I hope your project also finished setting up. So this is our scene. If you don't have this kind of scene, as I've told you, you can always go to layout and choose the default layout, and we'll have the same layout, both of us. So before we start, let's first of all add something called the console. And as you can see, even before we start anything, we have this console window right here. And what this does is it shows us the messages, and we're going to use this console window to see the things that will print from our code. And if you don't have it, you can simply go up here in window, click on it, and just above here you can see on the general we'll have the console. So click on it, a window should appear, and you can dock it wherever you want. I'm going to dock it right here next to projects. Another thing I want to talk about is in the wherever you've saved your project. I've saved it in D, Unity Projects, and Hello World. So as you can see, we have different folders right here. We have the assets, which hold our scenes and everything that we create in projects. You can see the assets and project assets right here. We also have the library, which automatically is created every time we enter a project. We have logs, we have packages, we have project settings. All of those are details that will not get into too much, and the temporary folder, which we'll discuss later on in the Magic Cube 2D game. So let's go back into Unity, and in here we are going to be creating our script. So let's right click in here and let's go into create, and in create we can actually create multiple things. As you can see, we'll do a couple of them in our project, but for now let's simply create a C# script. So click on that, and before you do anything, so now don't do anything, leave everything. You'll need to make sure that whenever you name a script that you do it with precision, because it will cause error later on if you want to try to rename your script. So make sure you name it correctly from the get-go. So we'll name this Hello World without any spaces, and click on enter when you're sure that you have decided on the name of the script. So click on enter, and I'll tell you why in just a bit. So as you can see, we have something right here in the inspector, and it took a bit of time, and it's because Unity needs to compile the code right here, and you can actually see the code in the inspector. And why I told you it's so crucial to make sure that the name of the script right here is defined before we click on enter. It's because it is going to be the name of our class. So if you change the name of our script right here, the class name won't change, and there will be an error where Unity or the Visual Studio will not be able to find the correct script in the project, and this will cause errors. So to avoid that, simply make sure that you name your script correctly and precisely from the get-go. Now, what should we do next? It's very simple. You simply double click on Hello World, and the Visual Studio should open up. And as you can see right here, this is what we've described a couple of maybe in the previous video. So what are we going to do in here? We are simply going to print something to our console, and we'll do that inside of start. So let's go ahead and print. So as you can see, immediately Visual Studio, our great friend, starts to help us, and it gives us suggestion for what we want to use. So we write the print, it gives us the suggestion, and now you can simply click on tab and it will finish it for you. And now we open up our brackets, and we can see that Visual Studio again helps us, and it tells us that we need to add a object message inside of here, and that object message is going to be a string. We'll talk about strings later, but for now string is a string of characters that we put inside of these two quotes right here. So let's go ahead and add these two quotes again, and now we write inside of these two quotes Hello World. So is that enough? Well, actually no, because if you see right here, we have this squiggly red line, and if we hover over it, it tells us that it expects a symbol, which is this one, and every line of code in C# you have to add this semicolon right here. So save that, and now because we've put it inside of start, as soon as we start our game, this message should be printed on the console. So let's try that. We go back into Unity and we go into console, but if we click on play, as you can see, nothing is being displayed on our screen. Why is that? Because it's not enough just to create a script. You actually need to attach it to an object. So let's create an object. And the way we do that, we simply go into our hierarchy, we right click on here, and we can create a empty game object. Click on that, and now we have a game object. Let's go ahead, we can change the name of that game object. We'll call it, let's call it Hello World Object. Click on enter, and below it you can see that we have the transform, and this transform tells us the position of our game object in the world. And up here we have the tools to manipulate. So if you click on this tool, you can actually put the object up or drag the object down, take it to the left or to the right, and put it anywhere we want. And currently we cannot see, we don't have anything to represent our game object. We simply have its coordinates and its transform. So let's attach the script to this game object. To do that, you simply click on the script and drag it into the hierarchy, into the hello world object. So if you click on hello world object right here, you can see that it has a script just below the transform attached to it. And now if we click on play, in the console we can see that we have hello world. Congratulations, you've just written your first code and you've just used your first game object to display something to the console. Great. And now it's time for your challenge. And your challenge is going to print your own name. So instead of hello world, you'll need to print your own name. So change hello world to hello, and instead of those 3 dots, of course, it's going to be your own name. I'll give you a couple of hints. So add your name inside of the dots. Save Visual Studio. Always remember to save Visual Studio using Ctrl S. Go to Unity and click on play and check your console. So make sure it works. Pause the video right now and go do the challenge. Okay, welcome back. How did you get on with that? I hope you tried your best in that challenge. Let's go into Visual Studio, and instead of world, I'm going to delete that and I'll put my own name, which is Michel. So hello Michel, and we'll just add an exclamation or 3 exclamation points for the dramatic effect. And to make sure that you've saved your project, I mean your script, when you look up right here, you can see that it has a small asterisk attached to it. And to save that, you click on, and that means it hasn't been saved. So if you hold Ctrl S, click on Ctrl S, you can see that the asterisk disappears, and that means that the script has been saved. Go back into Unity. You can see that there is an asterisk right here also next to the sample scene. So save that. And now if we go to console, you can see right here that we have this button clear. Or if you click down, you can see that we can clear on play. You can remove that, feel free, it doesn't matter. We'll just remove it to see the changes that happen. And now if we click on play, we will have hello Michel, or hello whatever your name is, my fellow student. And that is all. So clear that, let's try that again. Click on play. And hello Michel, hello my favorite game developers. I hope you enjoyed the video and I'll see you in the next one. Welcome back my fellow game developers. In this video we are going to be learning everything about version control, source tree, and creating repositories of our projects. So as you can see right here, we've created a new project. We started our big project, which is Sprite 2087, and we've downloaded source tree. We now have a couple of commits in here, and we actually reverted something. We've created our initial commit, added a cube, reverted it. We can actually reverse this commit again. So click on yes. As you can see, we can go back to Unity, reload, and we have our cube right here. We will be learning everything in minute detail. So give me your entire concentration. This is very important. It's an extremely helpful video or lesson, and it will stay with you forever as long as you are committed to becoming a professional programmer or game developer. So let's not waste any more time and let's get started. Okay, so version control. Let me put on my laser. Version control. It's hard to learn, it's even harder to teach, but I'll try to keep it as simple as possible. And when you get the hang of it, trust me, it's very simple and easy to use. Plus, it's an indispensable skill that you need to learn if you are looking to become a professional game developer or even a professional programmer. So let's get started with what is it. First of all, it's a system that is responsible for managing changes to computer programs. So this means that whenever we create changes in our programs, we can actually save those changes at each step of our project. This way we can first of all check what we did. We can create different kinds of versions where we can go back and change the things that we've created. It allows for a better teamwork. So for example, let's say you have 4 or 5 people working on the same project, but each one of them has a different task that they need to create. So version control is a very good way of handling all of this. And why do we need it? Well, why we actually use it? Well, we'll use it to remember previous version of our game and have more flexibility to experiment. Usually game development is an environment where you require a lot of experimentations. For example, you want to add some kind of property to some kind of game object and maybe it breaks your entire project. So you want to always have a previous version of your project before adding this game-breaking mechanic, so you can always go back and start fresh from there. So this is extremely important, especially for game developers that always need to be experimenting with new ideas and things in their games and projects. And how are we going to use it? Well, we are going to be using something called source tree. And this is version control. It allows us to create different versions, and it's, first of all, it's for free. It's very easy for beginners, very flexible, and it has a very simple interface that we can use as beginners. So let's go ahead and download source tree. Let me show you where we can do that. If you open up Google, Chrome, or any browser that you have, simply go to Google and write in here download source tree. You should find a link right here and it should be the source tree app. When you click on it, you go right here to their website. If you scroll up, you can see that you have the option to download for Windows, but if you are on a Mac, make sure that you click on here and you download the source tree for Mac OS, or it will not work for you. So if you have a Mac, download the Mac version. If you have a Windows, download the Windows version. Simple enough. Now, when you finish downloading, you should get this file right here. And when you double click on it, you should start the installation. Now, because I already have source tree, I will not be installing it another time. I will just take you through the process of actually installing it. Okay, so this is the first window that will pop up for you. First of all, you'll need to agree to the license, of course, and you can maybe turn this off if you don't want any emails your way from source tree and etc. Atlassian. Next thing you'll need to do is you need to create an account on Atlassian. You can go to Atlassian, and Atlassian is the parent company of source tree. You can go ahead and create an account there, or you can use an existing account if you already have a Gmail. I personally created one using Gmail. It's much faster, it's way easier, and they don't spam you with a lot of emails. Next thing in here, we are going to connect it to an account. Now this is, of course, we will not be doing this. This is if you want to host your code on a certain website like GitHub or Bitbucket. We will not be doing that, so you can simply click here on skip setup. Finally, while installing, source tree will tell you that it is unable to locate Git. So in order to complete this, simply click on download an embedded version of Git and continue on. And then it may also ask you for something called a Mercurial. Now, Mercurial is a different system, just like Git. It allows us to save different versions of our project. We will not be using Mercurial, so you can simply click on I don't want to download or I don't want to use Mercurial, and this should be it. When you finish installing, you should have this right here and your this window right here when you start source tree. If you don't, simply click right here on create and you should get this window. Now this is where we actually create our repository, and in here you can see that we have the destination path, the name, and the type of version control that we want to use. Of course, we'll be using the Git. We also have the option to create an account, but as I've told you, we're keeping things very simple. It's our first time, so we will not be creating any account. So in here, we are going to choose what is the destination path of our repository. So what is the project that we are actually going to be creating a repository for and subsequent versions of. Well, let's create our first project that we are going to be using. So in here, let's open up the Unity Hub. And as you can see, we already have Hello World that we've done in a previous video. Let's click on New and let's make sure it's a 3D project. And this is going to be our Cyber Spy 2087. Let's go ahead and create this project. So click on Create. And I, of course, always using my magic of editing in order to speed up this process. I'll see you on the other side. Okay, welcome back. So I hope everything worked out for you. So now we have a new project, which is CyberSpy 2087. So now that we have our project created, we can actually go ahead and get started with creating a repository. Now, if we go back into our source tree right here, we can click on Browse and we can actually go ahead into Unity projects, and you can see that we have a Hello World and we have a CyberSpy 2087. So let's select this folder. It will create a repository under this name, and if we hit create, it will ask a problem. Don't worry about it. Click on yes, and voila. Now we have actually started creating a repository. You have the staged files right here. You have different kind of knobs. You don't need to worry about any of them. For now, just focus on the staged files, unstaged files, and commit up here. Now, if we scroll down in these unstaged files, you can see that most of them are from the library. We scroll down to the end, we can see some of them are temp or temporary. We can see also that we have project settings, and these are all the files that we have for our project. We also have assets in here for Unity in the scenes, for example. So this is a repository, which is a version of our current project. Now, the problem here is, as you can see, there are a ton and ton of files, and we will not be needing all of them. Well, actually, we'll need almost none of them. We will need only a certain kind of files. So we want to be ignoring the library and the temporary files. Why is that? Well, let me show you by opening up the directory of our current project. Okay, so this is CyberSpy 2087's directory inside of Unity project, as you can see up here. So we have the assets, the library, logs, packages, etc. and etc. Now, what is the temporary folder and what is the library folder, and why don't we actually need them? So temporary is just a way for Unity to open up faster whenever we start the project, and it's always created whenever we open a project. So for example, if I go into Unity right here and I actually close it, you'll see that the temporary file will disappear. And even if we delete the library right now, so let's go ahead and delete this library entirely. If we go back into our Unity Hub and open up CyberSpy 2087, As you can see right here, you saw that the library has been created again and the temporary folder has also been created. So of course the project should take a bit more time now to open up, but this is evidence that a library and the temporary folders are not necessary for us to always commit and stage. And what do I mean by stage? So whenever we stage our folders, we actually create a commit from them and a version of them, and library takes up a lot of space. As you can see, if we scroll down, it takes up most of the space and we don't want any of them at all. So how should we proceed? Well, we can actually ignore all of the folders that are under the library by simply going and choosing any of the folders that have library on them, right click on it, and in here you can see that we have the option to ignore one of them. So click on ignore, and in here you have the option to ignore this exact file name, ignore all files with this extension, or you can ignore everything beneath a library, and this is what we want. So click on OK, and as you can see, everything under library has now been ignored, so we cannot stage it, so we cannot save it to our newer version. And if you scroll up, you might have noticed that we have a new folder in here that is the .gitignore, and when we click on it, on the right you can see that it has the library in it. And if we double click on it, we can actually open it up in our notepad, and in here we can add the different files that we also want to ignore. So what are the files that we want to ignore? Well, there are a ton of files, but thankfully somebody has actually gone through all these files and created a list of everything that we can ignore whenever creating version controls or versions of our project. And in order to find that file, you can go again into Google, our dear friend. Go ahead and search .gitignore unity, and you should have this link right here for the github.com. It will be hosted on GitHub. If you open up this link, it will take you right here. So this is the .gitignore, and it's the unity.gitignore, and these are all the files that we can ignore when creating versions of our project. You can click on raw right here, and it will open up this window or this tab. Let's go ahead and select all of them by clicking on Ctrl A. We will copy all of this using Ctrl C, and we are going to paste it in here in our .gitignore notepad. And now we have this gitignore notepad filled with all the files that we will not use for our repository. We will save that using Ctrl S. And now back in Unity, or I mean back in source tree, you can see that when we hit the gitignore, everything is ignored. We will stage all of that. And when we stage all of that, you can see that these are the files that are going to be committed, and these will be our initial commitment or our initial repository version of the project. And usually whenever you create your initial commit, we call this the initial, you can capitalize it, the initial commit, and we click on commit right here. So now if you look on the left, you can see that we have branches under here and we have the master branch. Congratulations, we have created our first commitment. Very nice. Now let me just show you how we will move further down the line. Even though this video has been long enough, but I think we need to get a proper foundation for source tree and version control as we move through our project. So let's say we are in our project right here, and let's go ahead and create some kind of cube. So 3D object, right click in the hierarchy, 3D object, create a cube, and now we have a cube. Let's scale it up a bit. So scale it on the X, the Y, and the Z. Great, so now we have a cube in our scene. And now if we go into source tree, let's save that before we go. And it needs to save it to a certain scene. So let's, inside of scenes, this will be our sample scene. Sure, sample scene. Yes, replace it. So we have this sample scene back in source tree. Wait for it a bit, and you can see that we have uncommitted changes. So if we click on them, you can see that the unstaged files are changes inside of the scenes, which is the sample scene. And here you can look in detail what we've created. Now, it's a bit weird right here, but if you look closely, you can see that we've created box collider, and basically this represents the cube that we've added to our scene. So let's go ahead and stage all of that. We can click on commit right here and name this added a cube. Click on commit, and now in our master branch you can see that we have an initial commit which didn't have any cube, and now in our added cube we've added a cube. So congratulations. And as a final note, this may look a bit cumbersome, this may look a bit weird, but don't be afraid. This is very simple, and more importantly, it's extremely important for us to understand as we move through our project, create versions of it. And if we ever make a mistake, we can actually go back by right-clicking in here and reversing the commit. And yes, we can reverse the commit. If we go back into Unity, it will ask us for a reload. We reload, and now we don't have the cube or any game-breaking mechanic that we've added along the way. And now it's time for your challenge, and your challenge is going to be to download and set up source tree and the .ignore file. So download source tree, install and set up everything, create your 3D project in Unity Hub, set up a repository for it in source tree, ignore the library files, get the .ignore file and add it to your repository, create your first commit, and then create your second commit. You can even go ahead and try to maybe play around with a couple of things, add a cube, reverse the commit, see what happens, get comfortable with source tree. And if you're having a bit of trouble, you can pause the video on this list of things that you need to create. And you can also always go back and watch the video and see how I made everything and follow along with me step by step. So I'll see you in just a bit. So in the next video, we are going to be setting up our world, creating various materials, and starting our big CyberSpy 2087 project. So I'll see you there. Hey, congratulations, you are almost around the 20 to 25% down the course. You know that there are very few people that have made it that far, and you are one of those people. Congratulations, I hope you're having fun. So let's not waste any more time and let's continue on with our journey. Welcome back everyone to another amazing video. In this video we are going to be printing things to our console, but not using print but using Debug.Log, which will enable us to add warnings and errors, and we'll do that using a script that we've created in our project. We'll be adding it to our magic cube. So as you can see in the inspector, we have this script attached to it right now, and we'll be creating some code. Ooh, very scary, but not too much. And finally, we'll be committing our project. So let's get started. Okay, so first thing you'll need is this console window. If you don't see it just yet, you can simply go into Window and go into our, where is it? So it's in General, Console. Simply click on it and you should get this console window. It will be up here somewhere. You can simply dock it next to our project. Okay, great. If you look closely, you can see that we have clear collapse. So clear, what it does is it clears all of our console. I've checked it on clear upon play. We have collapse, which means that when we have several messages that are the same, it simply collapses them into a single message. And here on the right, we can see that we have 3 buttons that we can check and uncheck. One of them is messages, the middle one is the warnings, and on the right we have the errors. That's the scariest messages we can get. Okay, great. So next we're going to create our C# script. You are already familiar a bit with it, so go to our project, right click, go to create and click on C# script. Whenever you want to name something like this, make sure that you name it correctly the first time. We've talked about this. So what are we going to name it? Let's simply name this cube. Click on enter. Now we have our cube script. Excellent. So we can open this up by double clicking on it and Visual Studio will compile. Waiting for it anytime now. Loading solutions. And we should have everything in now. Okay, great. So as you can see, we already have some code in here. We won't be worrying about that. What we will be doing is we'll go into our start method, and inside we're going to be printing to our console. Now, if you went through the first section, you may realize that we used print, but now we're going to use debug. And as always, Visual Studio is extremely helpful. So debug, click on tab, it will finish it for you, .log, and open up the brackets. And as I've said, previously we've used print, but now we're using debug. Why is that? Well, debug gives us more flexibility and control, and it's technically better, and it gives us better habits for future coding. So what is the message we're going to write in here? The message will be, hello everyone, I'm printing from debug. Okay, put a semicolon there, and now we save it with a Ctrl S, go back into Unity, but now if we click on play, we should not see anything. And why is that? We only see our square in the scene, but nothing is printing to the console. That's because we haven't attached our script to anything. So let's go ahead and attach it to our magic cube, save that, and now when we click on play and go into console, we should have, hello everyone, I'm printing to debug. Excellent. Okay. Now it's time for your challenge, and you will need to add a couple of lines. So first thing, you'll need to add 2 messages that display on the console telling to the player to press a certain arrow key. Next, you'll need to add 1 warning message, and finally you'll need to add 1 error log message. And I'm going to be a bit helpful with you here. If we go into Visual Studio, I will give you a hint. So if we click on debug, if we .log, we can see that we have log error and log warning. So go ahead and get on with that challenge. Welcome back. How did you do that? It's not a very hard challenge, but it might be tricky if you're just starting off. So let's create our Debug.Log, and we'll change this here. We'll tell the player, if you press the up arrow, you'll jump, and below we'll write, if you press the right arrow, you'll move. Okay, and now we'll need to create a warning. So let's go ahead and do that. .log warning, and simply when you open the brackets, you can click anything. If you press the space, nothing happens. And finally our error, which will be debug.log error, and inside of it, what should we write? If you smash the keyboard, nothing happens. You just cry. Okay, save that. Keyboard, okay, nothing happens, you just cry. Save that, go back into Unity, everything should be compiled, and if we click on play, hello. Okay, great. So if you press the up arrow, you'll jump. If you press the right arrow, you'll move. And we have a warning that if you press the space, nothing will happen, and an error. If you smash the keyboard, nothing happens, you just cry. Great, I hope you enjoyed this. Oh, and one last step, click on play, save everything, go into source tree, because we have uncommitted changes. Now, I don't think I'll be doing this every single video, but you should know that whenever we make changes to our game, we should always commit them. So stage all, click on commit here on the far left corner. And what should we call this? We'll call this adding a script with Debug.Log inside. Okay, great. Commit that. And we have it in our master branch, and I'll see you in the next video. Welcome back everyone to another video. Today we are going to learn about variables. So we'll learn what variables are, we'll learn how we declare those variables, and we are going to learn how these variables make our code more flexible. So as you can see here, we have some different kind of messages because we've integrated those variables into our Debug.Log. And here in our code, we see that we have 3 new variables. One is integer, the second one is a string, and we have also a float. And we've added those variables into our Debug.Log. So let's not waste any time and let's get started. So variables, what are variables? Well, we can think of variables like boxes. You have a box that we call lives, and we want to put some information or something inside that box to hold it. So we put a 3 inside of it. And what is that 3? Well, it's an integer number. How do we write that in code? Well, we have this way of writing it. It's an int, which means an integer, lives equals 3. But what do these even mean? Well, first of all, we have the type of the variable. We have the type here is integer. We have the name of our variable, which is lives, and it's a common tradition in coding, if you like, of naming the variable where the first letter will never be capital, and all other words inside of the variable name will be capitalized. And finally, we have the data, and the data should reflect the type that we give it. So what other types do we have? We have float variables. For example, if you want to talk about velocity, and velocity can be 4.8, and the way we write it is we write float velocity and 4.8 f. Whenever we want to make a float variable, we add f to the end of it. Then we have boolean, and as you can see here, we've named it is dead, where the first word of is not capitalized, while the second one is capitalized. And a bool or a boolean can be either true or it can be false. And we also have a string variable. A string variable means that it's a string of characters. Or for example, here we have the box called my name. As you can see, also the second word is capitalized. We write string my name equals Michel, which is me, and we put it inside of a box, and now we have a variable of string. Okay, great. So how are we going to translate that into our personal code? We're gonna make this Well, what actually happens is variables make our code more flexible. They help us manipulate the code in a better way. Let's demonstrate that. Let's go back into our Visual Studio and let's go ahead and create a variable. So, first thing first, if we create a variable inside of start right here, we can only use it inside of start. But if we write it outside of our start method, we can use it anywhere we wish in our code. So let's do that first. So what variable should we use? Well, let's create an integer variable. So let's say that we have an integer. We'll name this integer number of times and we'll assign it a value of, let's say, 5. Okay, save that. And as you can see, it's black and white, or it's a bit transparent. That means that we still haven't used it. And now let's use it. So if we go ahead in Debug.Log, it says if you press the right arrow, you'll move. So let's go ahead and add something to it. To add a variable, we simply do the following. Click on space, close the bracket or the little column in here, and then we write plus, we write number, and Visual Studio, as always, is our best friend and helps us. Simply click on tab, it finishes, and we save that. And now we have a variable inside of our debug. Let's see what happens in in Unity. Let's go ahead, clear all of this, and click on play. And as you can see here in our message, if you press the right arrow 5, you'll move. We should have added 5 times, but you get the picture. So now let's add a string variable. So let's go ahead and click right here, string. We'll name this name of the key, and our string will be, let's say, space. So space. Okay, so space. And now we want to add it to the warning, for example. So instead of writing space here, we'll simply open this and close it on the other side. Write plus and name of the key, and then another plus, and now we have a string variable inside of our log warning. We save that, we go back into Unity, and when we click on play, we should see here that it's space. Well, that wasn't very helpful because we don't know if it worked. So let's change this from space to enter. Let's make this also all capitalized. Save that, go back into Unity, click on play, and this should change to enter. And it did. So you can begin to see how flexible using variable makes our code. So instead of going and looking for every single name, we can simply add a variable and change it from the top, and all subsequent uses of it and our code will change. So what now? Well, I think you know, because it's time for your challenge, and your challenge is to create your own variable. So you need to create a variable of type string and use it inside of the Debug.Log, which we already did. So go ahead and make your own variable. We're going to create a variable of type integer and use it in one of the warnings. And finally, we're going to create a float and use it inside of the error logs. So pause the video right now and go try and do your best. Don't worry about messing things up. That's why we have version control. I'll see you in a second. Okay, welcome back. So how did you get on with that? It shouldn't be too hard. So let's go ahead. We've created our string, we've created our integer. Now it's time for our float variable. So let's go ahead and create a float. What should we call this? We'll call this at a speed. We'll simply call this speed. A speed of breaking, and we'll make this value we'll make this 6.94. Okay, great. And I've made a mistake here. It should be 6.94f. Okay, so let's go ahead and add it here in our Debug.Log error. So if you smash the keyboard, let's click here, at a speed of, let's simply add this, and what should we write here? Speed of breaking, click another plus, and now if we go back into Unity, click on play, it should tell us that if you smash the keyboard at a speed of 6.94, nothing happens, you just cry. Okay, I hope you enjoyed the video. I know that the variables and the messages in the debug log don't make a lot of sense right now, but you will see that later on it will be very important. So I'll see you in the next video. Welcome back, my fellow game developers. In this video we are going to be responding to our players' input, and that will happen how? Well, if we click on play right now, we don't see any messages until we press the up arrow. It gives us a message that tells us up arrow key was pressed, and if we press the left arrow, it tells us left arrow key got pressed, right arrow, and the down arrow. And we did that using some magic code. Ooh, very scary. But don't worry about it, I will take you step by step, and in fact in this video you are going to do that, not me. So let's get started. Okay, so as the title of this video suggests, we are going to be getting our players' input. And for that we'll use, for example, the up arrow, the right arrow, or the left arrow, and based on that we are going to print something on our console. But in this video we'll be doing something different, because my goal in this course is not to just show you how to create a game. I want you to become an expert problem solver. So in this video I'm going to tell you the problem that we have, and I will take you step by step on how I usually solve my problems. So first thing we're going to do is we're going to think of our problem. So the main problem is we need to get our player's input from a certain key that he pressed. He or she of course presses. So the keywords to look for are input and key. And whenever we face something that we don't know, Unity has a great documentation site. So we can actually Google it. So we go into Google and we simply write input Unity. We get all these search results, but what we are looking for is the documentation, which is scripting API input Unity. If we click on that, it takes us to this documentation. So we see that we have input, we have description. You can always read all the documentation, but you'll of course read it later. You don't have to get specific in every detail, just a glance over to see what it has. So as we scroll down, and we know that we need a key that will tell us what key the player pressed, we can see that we have multiple static methods in here. And one of them is called getKey, which returns true while the user holds down the key identified. Now, as we've said, our problem doesn't consist of a player holding down a key. We only want to return something or get a response from the game, whenever a player clicks or presses a button, doesn't hold it down. So if we read below it, we can see that return true during the frame the user starts pressing down the key identified by name. This looks like something we could use. So we click on get key down, and it takes us yet to another Unity documentation. And here is where we begin to read our description, which says that it returns true during the frame the user starts pressing the down identified by name. Great, this is what we need. And even if you don't know how to actually code it, if you scroll down just a little bit, you can see that we have multiple examples of this. And here we have this amazing example, which tells us that they are actually putting this get key down inside of update and using something weird, which is an if with some parentheses, and I don't know what that is. It's so weird, it's so difficult. Let's not trouble our heads with it. Let's simply copy this. So we'll copy this, and of course we'll be explaining if conditions later, and we go back into our Visual Studio, and as they told us in the example, we will paste it inside of update. Okay, great. So I do a small explanation of what we're actually doing here. So if condition works as it says. If anything inside of this place here, inside of these two brackets, is true, we will execute any code inside of these two curly brackets. Don't worry about if conditions if you're new to them. We'll be explaining them in more in-depth in later videos. But for now, paste this inside of update, save it, and let's go back into Unity. Click on play. Now we press the space bar. The space key was pressed, and pressed. Okay, great. But as we've said, we are not looking for the space, we are actually looking for the arrow. So how are we going to do that? Well, we hope that our good friend Visual Studio will help, and it will. So if we double click here on space and delete it, delete the little point, and if we click it again, as we see, it gives us a lot of options. So what are we looking for? We're looking for the up arrow. So let's write arrow, and voila. It gives us all the options that we can use, and one of them is the up arrow. So simply click on tab, and now it should work when we press the up arrow. So let's remove this, and actually instead of space, we write up arrow. Okay, nope, not, excuse me. So save that. Let's go back into Unity. Go back into Unity, clear all of that, and click on play. Wait for it to compile, and now if we press the up arrow, we should get up arrow key was pressed. Okay, great. One more thing I want to do. Let's comment all of these out, and the way we do that is with 2 backslashes, just as we have comments in here, just so they don't get in the way. And now it's time for your challenge, and your challenge is to finish the rest. What do I mean by finish the rest? Well, now you have to finish if the player pushes the down arrow, and if the player pushes the left arrow, and then small extra challenge for those of you out there that are very motivated if the player pushes the spacebar. Even though we've already done it, I want to see how you do it. So pause the video right now and get on with the challenge. Okay, welcome back. How did you get on with that? So let's simply go ahead and copy this. There's no shame in copy pasting code, even though it's better to find a better way to do that. So what will we be using in here? We'll be using the down arrow, and we'll copy this also and save ourselves as much time as possible. So up, down arrow, and in here we're going to use the left arrow, and also copy that. And just for the sake of being even extra nerdy, we'll make one for the right arrow. So right arrow, copy that, and here we'll simply write arrow. Let's make this capital letter, save that. And now if we go back to Unity and click on play, all of this should clear. And now if we press the up arrow, we get up arrow key was pressed, left arrow key was pressed, right and down, and everything is working fine. And before we go, don't forget to commit our changes. Don't worry about if I have some extra changes here. These were just experiments. So stage all, click on commit, and we'll write here added a couple of player inputs. Okay, so commit that. Everything is working fine. It's in our masters, and I'll see you in the next video. Welcome back, my friends, to another video. In this one we'll be using rigid bodies and we'll be using box colliders. How are we going to use them? We'll use them adding components. And why are we going to use them? Well, because now our cubes are not just images, they actually fall. And not only do they fall, but they get caught using the platforms that we've created. So let's not waste any more time and let's get started. So now if we click on play, our cube doesn't do anything interesting. And what we wanted is we want to at least make it fall. So how do we make this cube fall? And hence, how do we add a gravity to it and make it a physical, real object? We do that using a rigid body. And what is a rigid body? Well, rigid body control allows us to control an object's position through physics simulation. I know it's a handful, it's big words, but if you go to Unity's documentations, which I've left you in the resources, you can actually read all about rigid bodies. And rigid body object will be pulled downwards by gravity without adding any code, which is amazing and exactly what we need. So if we go back into Unity, we can actually go into our magic cube, and if we look here on the right to our inspector, we can see that we have a transform, we have a sprite renderer, and we have the cube. So transform tells us the position that our cube is at. The sprite renderer actually renders our cube, so if we turn it off, boop, it goes away. Turn it back on, it turns back, and the cube is our script. So let's make all of these smaller, and we have here this button which allows us to add components. So if we click on add components, we can actually search for rigid body, and we have two rigid bodies. One is rigid body, which is used for the 3D world, and the rigid body that we will need, which is rigid body 2D. Click on rigid body 2D, and now we can see that we have a lot of options and information and constraints and body type and mass. Don't worry about all of these. We won't be using all of them, but if you're interested and you want to go deep into the rigid body subject, you can read all about them in the Unity documentation. One thing I will be glancing over is the body type, which we have dynamic, kinematic, and static. Now later on we will delve even deeper into these three, but for now what you need to understand is that dynamic is when our body is subjected entirely to the physics world around him. Kinematic is when our body is not affected by gravity but could be affected by other forces, and static is an object that does not move at all whatever happens to him. So we need our cube to be for now dynamic. So we've added a rigid body. Let's save that and let's click on play and see what happens. If we click on play, whoop, our body or our magic cube goes down and leaves our scene, and we have no idea where it went. It goes away into, I don't know what's called down there, maybe hell or anything, but it disappears. So how are we going to hold it? Because for now it's not that magic. We'll do that using colliders. And what are colliders? What is a collider? A collider makes it possible for objects to interact and hence collide with each other. So whenever our collider or whenever our body has a collider and it touches another body that has a collider, they will collide and stop each other. We'll use it to catch objects that are falling because of gravity. So we're going to use this collider in order to catch the object that we have. So let's go back into Unity and close down this rigid body and add another component, and we can actually search for collider. And as you can see, we immediately have tons of options. We have box colliders, we have box colliders 2D, capsule, capsule 2D, circle, circle 2D. So because we're using our cube or square, we'll be using a box collider 2D, which is ultra simple. And as you can see, we also have tons and tons of options. You can read all about them. I of course left it in the resources, but one thing we need to focus on is this is trigger, and this will be useful later on in the course. But for now, let's just zoom in and see what we have. We can actually see our box collider. It's green, it's a green line all around our box, but we cannot see it right now. The way to see it is if we click here on the edit collider, and we can actually make this collider bigger, make it this way, and actually make it outside. So this is the collider. This is actually where our object will be colliding with other objects. So let's reset all of that. And let's see what happens if we click on play. So exciting. And then, whoop, nothing happens. Why is that? It's because you have a challenge. And your challenge is to catch the falling cube. Don't worry, I won't leave you alone. Because first of all, you need to create another cube and size it to platform size. What do I mean by that? Well, you need to make our platform from this end right here all the way to the other end in order to catch our cube. So let's continue with the hints. Create another cube and make it a platform. Add a rigid body, and don't forget to change the rigid body type to static. And finally, add a collider to our platform and catch our cube. So pause the video right now, give it your full attention, give it your full concentration, and don't worry about making mistakes, because mistakes are the best part of learning. It's either you do something well or you do it wrong and learn from it. So take your time and do the challenge. Okay, welcome back. How did you get on with that? I hope you didn't just stare at the screen for like 5 seconds until the video continued. Okay, so now we take our magic cube, and what we'll do is we'll duplicate it. And we can duplicate it in two ways. We can either right click on here and go to duplicate, which will create another game cube, or we can simply click on Ctrl D. And now we have another cube if we take it here below. Let's make this cube a little bit bigger, and the way we're going to do that is by scaling it. So here we have the scale in the X direction, and we have scaling in the Y direction and in the Z, but because it's 2D it won't scale anyways. So let's bring back Y to 1. And let's increase the X scale until it fits between the two sides of our game. Now we have a platform, and let's differentiate a bit between them. So let's make this platform a bit darker. We can change the color in our sprite renderer. Here we have the color, and if we click on it, we can make it a bit grayish or blackish. So let's make it black, and we'll make the square here, let's make it keep it white or make it a bit gray, Let's see, maybe let's just keep it white and let's change the background. Ooh, very fun. So we can go into camera and actually change the background color, which will make gray. Okay, seems gray enough. And let's lower this magic cube. Actually, let's change its name to platform. Oops, wait. Platform. And now we have our platform. Let's lower this down. And these are the edges of our camera. So now if we save that, and oh, I forgot something. Good thing I remembered. We click on platform and don't forget to make this static, or else it will just fall away, fall down into whatever down is. Click on play, and hopefully, yes, it holds. Amazing. I hope you liked the video. I hope you did everything and commit everything we done. So committed, added, well, actually made my magic cube fall and held it with a platform using rigid body and colliders. Great. So stage all, commit, and I'll see you in the next video. Welcome back, guys, to a brand new video. And as advertised in this video, when we click play, our cube becomes magic. How is that? Well, if we press up, he jumps. If we press left, he goes left. If we press right, he goes right. And if we go up, 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 we can actually press down, 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 and make him come back faster to Earth. So let's get started. Okay, so first thing we'll do is we need a reference to our rigid body. What do I mean by a reference to our rigid body, and why do we need it? So reference to a rigid body means that we'll write up here public, and don't worry about public, we'll explain it later, but for now public means anybody can use it. So public rigid body, it's a variable of type rigid body, and we'll call this my rigid body 2D. Okay, save that. Now how are we going to tell this that it is the rigid body on my current object? Well, if we go back into Unity, clear those messages, pesky warnings, and if we click on cube right here in the inspector, we can see that now we have an empty slot for a rigid body. So if we click on the little circle to the right, we can see that we have the magic cube or the rigid body of the platform. So let's go ahead and click on the rigid body on our cube. Double click on that and save it. One thing I just noticed is that if we click on our platform, oh, it's actually, we made a mistake. We shouldn't add the rigid body. In fact, we should remove the cube. So let's remove the cube component from the platform because we don't need it to move. That's something we should have done in the previous video, but that's no problem. Go back to cube, and now we add a rigid body, which is magic cube. Excellent. So save that. Now we have a reference to our cube. Next thing we're going to do is we are going to add velocity to our rigid body. So if you went through the documentation of the rigid body in Unity documentation, I think you have noticed, or maybe you didn't, but there is a component, or how do we call it, a property in my rigid body that we can use in order to manipulate the velocity. So now our arrow keys no longer print things to the console. Our arrow keys now actually manipulate the velocity of our rigid body. So let's do that. So in order to access the velocity, we will write my rigid body 2D, which we now have a reference for, dot velocity. Now if we glance over velocity, we see, and actually Visual Studio tells us that it's a vector 2. What is a vector 2? Well, a vector 2 is a vector in 2D space. So that means it has the x coordinates and the y coordinates. Now you should be pretty familiar with x and y coordinates from school. It's not too hard of a math, but it should be. Now I will of course leave some resources in the video attached to this video where you can check out everything about vector 2s. Don't worry about it. It's pretty simple. To create a vector 2, all we need to do is write new vector 2 and open the brackets. Nothing too fancy, and inside those brackets we can actually go through multiple parameters that this vector 2 can take, and it takes a float x and a float y. So how do we want to move it? In our case, we are pressing the up arrow. That means we want the box to move upwards and not move to any side to side. So how do we do that? We simply write 0f in the x direction and 10f in the y direction. So 10f means it's a float because our parameters told us that the rigid body takes floats. So let's go ahead and continue the down arrow. Now, even though down arrow I don't think we'll be needing it, but for practice reasons we are going to add it, and being this is down, instead of 10f we'll make this minus 10f. So save that. Let's go into Unity and see if something actually worked. So click on play. Our cube falls to the ground, and if we press the up arrow, he actually jumps and then falls down. So if you press up, up, and then down, down, he falls faster. Excellent job. And now you know what time it is. It's time for your challenge. Complete the magic. So you have to finish adding velocity using the left arrow, and then you need to finish adding velocity using the right arrow. So pause the video right now, go ahead and do the challenge. Welcome back. How did you get on with that? I hope everything went well. It's very easy. Let's simply copy that. And now when we add it to left, we will have 0f in the y direction, and we will add it minus, let's say 10f. Let's keep it 10. And in the case of the right arrow, we'll add 10f in the x direction and 0f in the y direction. Go back into Unity, click on play, and now if we press on the left arrow, we should move left, right arrow, we move right, up, 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 down, down. Everything works perfectly fine. Final step, as always, I don't think I will keep doing this, but for now, just to get you in the habit of doing it. So assets, should we call this? Well, made my cube move left, up, down, and right based on the arrows with an exclamation mark. So commit that, and I'll see you in the next video. Welcome back everyone to another video. As the title suggests, we are going to be learning about if conditions, and we are going to be learn how we can manipulate them. So if we click on play right here, if our box moves to the left, our console prints that our cube is out of bounds to the left, and if we move to the right, it tells us that our cube is out of bounds to the right side. And the best part is, if we jump, it tells us that our cube is out of bounds to the upper side. So how are we gonna do this? Using if statements. So put your concentration caps on and let's get started. Okay, so before we start, let's talk about what if conditions are, why we use them, and their structure. So conditional if statements They are, as the name suggests, they are code that we execute only under certain conditions. So this is the structure of an if condition. We've used it before in our arrows in player inputs. So if some condition that needs to be true is true, we execute whatever code is inside these curly brackets. So if we put in a boolean, as we've said, a boolean can either be false or it can be true. So if that boolean is true, we execute the code that is inside the curly brackets. Now, if this statement happens to not be true, we will simply just avoid or not even consider the code inside of the if statement. But if we add another else if, and as its name suggests, is if the upper condition is not true, we check for a second condition, which is some other condition that is true. And if that statement or condition is true, we execute the code inside of these curly brackets. And if both statements are false, then we finally use something called else, and this does not have to be nothing has to be true in order for this code to be executed. Only all other if conditions above it should be false. Now, we've used this else or if condition before. We've used it in our code when we tried to get the key down from the player. So how does this exactly work? Let's zoom in a bit. So input, this input, which is a class in Unity, uses the function or method getKeyDown. So if you hover over the getKeyDown, you can see that it's a boolean and it returns true during the frame the user starts pressing down. So whenever our player presses the up arrow, as we've told it here, and we did it using key code, which is another function in Unity, dot up arrow. If he presses the up arrow, it tells the getKeyDown that during this frame the up arrow key was pressed, and it returns true. That makes this code right here execute and moves our cube. And the same is true whenever we use the other if statements. So now what we are going to do is we're going to be creating our own if condition, and we're going to do that in our case for the game. So for now, if we click on play and we move our cube from side to side, whenever he gets out of boundaries, he falls down from our platform. And what we want to do, first thing, we'll make our platform just a little bit bigger. So we'll increase its scale, make it just a little bit bigger to give our cube a place instead of just falling into whatever down is. And now we're going to check for the coordinates on this cube. So this white frame right here is what our game actually sees. And if we dock our game view next to our scene view, and as you can see, it gets smaller. To fix that, we can simply go into game and click on this right here and simply make it into 16 by 9, and this should always keep our frame at the same dimensions. So now if we go into our scene, let's make this a little bit wider and click on our game cube or magic cube and move it, you can see at the top right in the inspector that the position changes, and this value can actually be accessed. So whenever our cubes goes outside the boundary, so let's say it should be right about here, which is 9.42. So whenever it goes outside the boundary, we want to print something to our console. And the same holds true whenever we go to the other side, which should be 9.40. We'll settle for 9.5. Okay, so how are we going to do that? Well, using the structure of if conditions that we just learned. So let's go ahead, save this, and go back into our Visual Studio. And we'll do this inside of update. So what are we going to do? We want to check if the cube has moved outside the right boundary. So if what should we write here? First thing we'll need to do is access the transform of our cube or game object. So it's transform, simply write transform dot position, and we're not looking for any position, we are looking specifically for the x position, so it's x. So if transform dot position dot x is greater than 9.5f, because remember it's a float, then inside of the if statement we want to execute some code, and for now we are simply going to print to our console. So we'll write Debug.Log. Let's make this a warning just for fun. So Debug.Log warning. So we should write something inside of it. Our cube is out of bounds to the right side, with 2 exclamation points to make it a bit more dramatic. So save that, go back into Unity, wait for it to compile and understand what is happening, and now clear all of that, click on play, and now if we move to the right side, as you can see our cube is out of bounds to the right side, and the more we move, but if we move to the left, nothing happens. So pause that, and now we'll make an else if statement. So else if, and inside of it, for our else if statement, we're going to check if our cube goes to the other side of our screen. So it's transform, again we access the position and we need only the x, and now we're going to check if it's smaller than minus 9.5f, and in this case we're going to also print a warning, which will be our cube is out of bounds to the left side with 2 exclamation points. So let's make this a little bit neater. Ctrl S to save all of that, go back into Unity, wait for it to compile, clear everything, click on play, and now if we go to the left side with our cube, it tells us that our cube is out of bounds to the left, and on the right side it tells us that our cube was out of bounds to the right. But now if we jump with our cube, nothing happens, because it's time for your challenge, and your challenge is to finish the last if statement. So finish if statement when our player goes out from the top of our screen, and I'll give you a couple of hints. We'll need to move the cube around in our scene and understand the top boundary, and we'll also need to use the if statement to print to our console. So pause the video right now, take your time with this challenge. I'll see you in a bit. Okay, welcome back. So let's clear this up and let's see our upper bounds. So if we move our cube, we can see on the right here that we have the y position changing, and if we take the y coordinates and check for them at about 5.5, our cube leaves the camera view. Okay, great. So let's go back into our Visual Studio and write another else if statement, and else if our transform dot position, and now instead of the x we're going to be using our y. So if our transform dot position dot y is greater than 5.5f, we will print another warning in here, and this warning, our cube is out of bounds to the upper side, also with exclamation points. Save that, go back into Unity, and let's wait for it to understand what we've done. Click on play, and now if we jump and we get out of bounds, it tells us that our cube is out of bounds to the upper side. Okay, so final step, let's move out of play, go back into our source tree, and now we can commit everything. So stage all, click on commit, and we'll call this adding if statements to my game. Click on commit, and I'll see you in the next video. Welcome back everyone to another video. In this video we will not be doing a lot of coding, but we will be restructuring our code. How are we going to do that? Well, as you see, our update method is a bit different because we extracted all of the things that are related. So for example, now we have a method that is moving our cube and it's right here, and we have another method that is out of bounds in our printer. Not only that, we've also created a public method which is printing from outside, which also has a parameter, so exciting, and it returns a string, and it's used not inside of cube, it's used in platform, a new script that we've created. I'm so excited for this video. I hope you are too. So let's not waste any more time and let's get started. Okay, so if we look right now at our start and update methods, we can see that they are kind of cluttered and there are things that are not related to each other. So for example, we have all of these if conditions that relate to our cube movement, and we have them right next to the if conditions we've created to understand the boundaries of our cube. So we need to restructure them in a way and to make it look more appealing to the eye. So we're going to do that using methods. So what are methods? Well, method structure are kind of like this. Just like we have the start method and the update method, we can also create our own method. And they kind of look like variables, but they are also kind of different. So we have first of all is the access type, and this is the accessibility. So we have two access types. It can be either private or it can be public, and we are going to use both in our project. So private is when a method is only used inside of its class. So for example, if you create a public method inside of cube, only cube can use that method. But if you create a public method, other scripts can use your method also. Then we have the return type, and for now we've only used the void, which means that we return nothing. We can have a return type of integer, for example, where a certain method returns an integer. It can also return a string, and it can return other things. We also have a method name, so the method name should always reflect what the method actually does. And as a convenience, just as we name our variables, the first word will always is not capitalized. When we are naming methods, our first word is always capitalized, and all subsequent words are also capitalized. And finally, we have parameters, and we have when a parameter has nothing inside of it, that means we pass nothing. And what parameters are, they are like variables that we pass to our method, and we can use them inside of our method only. So how are we going to use this method structure? Well, we're going to use it inside of our code right here. So let's begin by restructuring some things. So as an example, I will show you how much more efficient our code becomes. So let's remove all of these comments right here, and as you can see that every time we need to comment these debug logs, we need to go and do them one by one. Well, we can actually use all of these. If you highlight them, and of course you're using Visual Studio, and you right click on them, you can see that we have something up called quick action and refactoring. So if you click on that, tells you if you want to either extract it to a local function or extract it to a method. So if we extract it to a method, and by the way, the difference between a function and a method You can actually use them interchangeably and however you want, but functions are usually methods that are inside of another method. But a method is a method that is outside the method we're currently doing. So it's a bit confusing. You can use both of them interchangeably. Don't worry about it. So what are we going to name this method here? And we are going to call it printing to our to our console, and click on enter, and now we have this function or method right here. And as you can see, it's a private method that doesn't return anything because it's void. And now if we want to comment that out, we can simply comment this function out, and all of it is commented out and it won't be printing to our console. So this is the first benefit of using methods. So let's go ahead and put this under update. So if we click on Ctrl X to cut it, and we'll put it below update. I like to put update right below the start method to have a nice and cohesive structure to our code. Next thing we're going to do is we're going to extract two other methods. So first of all, we're going to highlight all of the if conditions in our for moving our cube. So highlight all of them and right click, extract a method. We'll call this method moving our cube, and we'll also extract this method, and we'll right click, go to extract method, and we'll call this method, what should we call this? Out of bounds printer. Okay, so now, sorry for that, get back to zoom in a bit. So now, as you can see, our update method is very cohesive, and we can easily see what our update method does. So it is moving our cube, and it out of bounds printer. It checks for out of bounds. Whenever our cube is out of bounds, it prints something to our console. So now you can see that we have this method right here and another one right here, and finally we have the printing to our console. Excellent. Now we're going to create a second script and create a public method just to demonstrate how everything is working. So first thing we'll do is we'll create a public method just under update, and we'll call this, well, first of all, let's make a public. We'll make this a void because we don't want it returning anything for now. Public void no, we'll use it, we'll call this printing from outside. Okay, you don't have to make your method names that long, but just for the sake of giving an example. So what this function will do, it will simply print something or a certain message that will have hello from the other side. I don't know why from is capitalized, it doesn't have to be. So it's hello from the other side. Let's go back into Unity, click on platform because it's the only other object that we have besides the camera. Let's add a component and let's create a platform script. So new script, platform. Excellent. Let's go ahead and create it, and in a bit it should be added. And now we have it in our project, so double click on it and it should open in our Visual Studio. And as you can see, we already have the void update method and the void start method. Now inside of start, we are going to get a reference to our cube script and use the public method that it has. And how are we going to do that? Well, we're going to do that using something called find object of type. And object of type has these two operators right here that we need inside of it to tell which script we are going to use. So it finds the object of type cube, and Visual Studio always helpful. And now if we click on dot, we can see that we can use anything that is inside of the cube. So if we, for example, want to access the start method, we can't. But if we want to print, as you can see, it gives us the printing from outside method because it is public. So if we save that and go back into Unity, and let's also save our scene and click on play. And before we do that, let's clear this up. And as soon as we click on play, hello from the other side. How cool is that? So we've created a function or a method that is inside of the cube, but we are using it inside of the platform. That is so cool, and this actually is the basis, and it's very crucial because we're going to be using it a lot in our game in the next sections. So your challenge is to create your own method. You will create a simple method with a string return type. So instead of void, you will have it as a string type. You will also give it an integer parameter, and you will use it with the string and return it. So it's a bit of a big challenge, but I think you are ready for it. And a small hint, use toString. And it will require a bit of research to understand and do the challenge. Take your time. Don't be afraid of making mistakes. As I've told you, trying and failing is not the end of the world. So I'll see you in a bit. Okay, welcome back. So now we are going to change our method just a little bit. So instead of void, we'll make this a string, and it currently doesn't take any parameter. So we'll give it a parameter, which is an integer, and we'll simply name this integer value to not be overcomplicated. But as you can see right here, we have a squiggly red line. That means that our function is not working properly. Why is that? Because it has a return type, which is a string, but it's actually not returning anything. So how do we fix that? Well, we need to write here return, and we need to return a certain value. And what that value is, well, it needs to be a string. So let's go ahead and create a variable inside of our printing from outside. So this variable will be a string. We'll call this variable printing something. And what will have it print? Well, the value we were sent is, and now we can use this parameter that we've been sent from the other side. And now in return, we will return print something, and that should fix our squiggly red line problem. But because we've given it a parameter in here, where we call it from should also give it a certain parameter. So we have to give it an integer, and that integer, let's say, will be 8 or 4 or anything. Or you can even create a variable right here. We'll call it an integer. We'll call this value to send, and it will be equal to, let's say, 9. And in here we'll send the value to send. Save that. This actually returns a string. So let's put it inside of a string reference, which we'll call string from outside equals. And now we'll simply Debug.Log, and we'll be printing the string from outside. So close that, save that, go back into Unity. So clear everything, click on play, and now the value we were sent is 9. Excellent job. And one thing I want to make clear is that because this is a string and this method returns a string, we can actually directly put it inside of our log. Excellent job, everyone. I hope the challenge wasn't too hard. I thought it was a little bit step up and it needs a little bit of research, but I hope you tried your best. And as always, before we go, we need to stage all, commit, created my first public method with a return type. Commit that, and I'll see you in the next video. Welcome back, everyone, to a new and very exciting video. In this one, we are going to learn about prefabs. Not only that, we'll learn about prefabs, how we can use them from scene to scene. Here you can see that we have a diamond with something called a polygon collider. We also have this magic cube and a small circle, but actually this circle moves with our cube because it is a child of that cube. We've also created a second level, level 1 and level 2. Here we have 3 cubes, as you can see, and for some reason they are blue, and we'll see why they are blue. We also have a diamond right here, and if we click on play, all of them fall down, and that's it. So it's so exciting. I'll see you in a bit. Okay, so what is a prefab? Well, basically it's a template for a certain game object. So if we created a game object with all its components and its script and its position, we can create a template from it to create other similar game objects. Prefab system allows you to store a game object with all its properties. So let's say our prefab has a collider, it has a rigid body, and it has a script. Whenever you create a prefab from said game object, you will have the same properties in it. So why do we use it for? Well, we can reuse a game object configured in a particular way. We can edit many objects at once, and we can use the same object in different scenes much easier. So let's go ahead and demonstrate these 3 uses. So creating a prefab is actually very simple. All you need to do is simply click on the thing that you want to prefab. So for example, we want to prefab our magic cube. Click on it and drag it into our project. And now we have a prefab of our cube. And you know it's a prefab by looking up at the hierarchy, and you can distinguish it because it's a bit more blue. Excellent. So now what can we do with our prefab? If we click on it, you can see that it has the same properties as the cube in our scene. And now if we click on the prefab and drag it into our scene, you can see that we can create 3 beautiful magic cubes extremely easily. And this is very helpful in many ways. So let's demonstrate how prefabs work. So let's say we click on this magic cube, which we see in the hierarchy is numbered 1. So let's say we want to change its color. So if we go into our sprite renderer and choose color, and let's make it red. So now we have a red magic cube. We save that, and you see that the other 2 magic cubes are still white. And by the way, these cubes are called instances of prefab. And if you look closely here in our inspector, you can see that we have another tab open. So we have the open, which opens our prefab, which is the magic cube. We can select the prefab and we can override. And what this does, it applies whatever changes that we've made to our current instance to our prefab. So the things that have changed, you can see that they are also highlighted in a blue color right here, and we changed the color. So if we click on override and click on apply all, what should happen is that all of the other instances of that cube change to red, and down here in our project you can see that our magic cube is red now. That is very cool, and you can start to see how helpful that is. So let's say we change back the instance to white. Let's take another cube and change that to green. So now if we apply this to our prefab, what do you think should happen? Will all of them turn green, or will only the one that is red turn to green? Let's try that, apply, and oops, as you can see that only the prefab that was originally, or the instance of prefab that was still the same as the original, is changed to green, but the ones that we've also modified don't change back. So prefabs are a bit tricky, but they are very helpful. So for example, let's go ahead and delete those 3 cubes. And let's go into scenes, and let's simply duplicate our current scene. By that we create a second scene. Let's rename this to level 2, and our original scene will be level 1. So now, yes, it asks you for a reload, simply click on yes. So now in level 1 we have these 3 cubes, and in level 2 apparently we also have these 3 cubes. So let's go ahead and delete them. Save that. So in level 1 we have the cubes. In level 2 we don't have cubes. So what are we going to do about it? Well, instead of going to level 1 and duplicating or copying the cubes, we can simply go to our project, and we have a magic cube, and we can add it easy as pie right into our scene, and now we have a cube, a magic cube in our scene. Okay, great. So that's a prefab. Now, what are children? Well, let's go ahead and go to assets and create a sprite, and the sprite will be a circle. So now we have this, let's say, magic child circle. Okay, so magic child circle. We can go ahead and add this magic child circle to our scene. And by the way, this magic cube is the prefab. This is just the sprite. By the way, we can also organize all of this. So if we create a folder, call this Sprites, we can put both of these into Sprites. We can also go ahead and create another folder, call this Scripts. And now we have these scripts inside of the folder scripts. And if we add another prefab, we can also create a folder for the prefabs. So now we have this magic child circle. Why do we call it the child circle? Well, because we are going to child it to our magic cube. And we do that by simply taking our magic child circle and dragging it right under our magic cube, and now it's a child. Now what does child mean? If we click on the circle, we can move it as we always do, but if we click on the magic cube and we move it, you can see that the circle moves with it. That means it is a child. And if we scale our cube, our circle also scales. And if we scale in the Y direction, it also scales. If we rotate, so let's see, if we rotate it, the circle also rotates, and these are properties of a child. It grows with its parent, and the parent is magic cube, so it grows with its parent, it shrinks with its parent, it moves and behaves just as its parent does. And this is very helpful because sometimes we may need to add children. So if we have an object that has several objects inside of it and we want them all to move in unison, instead of coding all of the children, we can simply code things to the parent and the children will move with the parents. So we'll be using a lot of parent-children relationship will be using prefab also a lot. And now it is time for your challenge. And your challenge is to create a new prefab. So create a new object in our scene, whichever scene you want, prefab it, make an instance of it in a different scene, and add a component to that instance, apply the changes to prefab and see what happens. And if you want, as an extra challenge, you can also make a child-parent relationship somewhere in our scenes. So pause the video right now and go do the challenge. Okay, welcome back. How did you get on with that? I hope it wasn't too hard. So let's take this cube, put it over here, our magic cube, which is a square, ironically. And now let's go ahead and create something. So we'll go into sprites. Let's see, we'll create a diamond because diamonds are forever. So diamond, click on enter, and let's go ahead and put it in our scene, and we'll put it inside of sprites. So now we have a diamond. Let's make this diamond a bit bigger, and let's change its color. So let's make it a blue because diamonds are kind of blue, I guess. So now we have this diamond in here, and what we want to do is so what was our challenge? It was make an instance in a different scene and add a component to the instance. Okay, so we take this diamond and let's prefab it. And now because we have two prefabs, let's create a folder, call this prefabs, and everything is organized and neat. So now we have the diamond. Let's go ahead, save that, go back into our level 1 scene, and we have 3 cubes here but no diamond. But we can easily add one from our hierarchy super easily. So let's add a component. Let's add a rigid body 2D, and let's also add a collider. And what kind of collider should we add to it? Let's go ahead and add a circle. Yeah, sure, why not a circle? Well, actually it should be a polygon collider. Let's make it a polygon collider, and it fits perfectly. And actually, just for the fun of it, let's go ahead and rotate it in the Y direction. Nope, not in the Y direction, I meant in the Z direction. Okay, great, so save that. But right now we are clicked, as you can see, we are clicked on the diamond in our scene, and we've actually added a rigid body and a polygon collider. So it's not added to our prefab. If we click back on our prefab in projects here below, we can see that it doesn't have any rigid body or collider. So back into diamonds, click on override, apply, and now in our second level, save that, in our level 2, wait, sorry for that, scenes level 2, the diamond actually has rigid body and a polygon collider, which is great. So click on play just to see it fall. Our diamond falls and everything falls, and as you can see, even the circle falls with our cube, but because it doesn't have a collider, nor does it have a rigid body, but it moves with our cube. So I hope you did the challenge. I hope you enjoyed this video, and I think this will be the last video in our section. In the next section, we are going to actually start creating our game. So exciting. So review this, make sure you understand everything in this section, and don't forget to always commit our work. So let's commit this, stage all, added a diamond prefab, and added a child circle to my magic cube. Okay, great. So commit that. It's saved. We have it in our commits right here, and I'll see you in the next video. Hey, you are almost 50% the way with the course. How cool is that? You know that you are one of the very few. I think less than 20% make it 50% of the way down the course. So congratulations, I hope you're having fun, I hope you're enjoying your time. Let's not waste any more time and let's get started. Hello and welcome back, my favorite game developers. In this video I'm going to talk a bit about game design, and as you can see I've already started and already the Google Slides are very excited to tell you about the game sketch. So the game sketch is the following. Now it's not very impressive, but it will get the concept of our game around. So you've already watched the introduction video where I've showed you the game that we have finished already, but now I will take you through the steps that it took for me to get the game developed. So first thing first, I've created this mini sketch, and as you can see, well, it's not very impressive, but it gets the job done. So first thing first, we have the tiles right here, which will define our world. And we have the background tiles or the world confiners right here on both sides. Next thing we have are the doors. So we'll have the enter door through which our Conqueror right here, this little guy, can enter through and start the level. And this is the door right here that he has to go through in order to advance to the next level or room. Next thing we have the bombs right here that I've sketched as burning, and they will explode as soon as we get near them. Well, not as soon as, they will start burning when we get near them, and they will explode eventually. We have the hearts that we can pick up in order to increase the lives we have. We have, of course, the hanging sheets right here that we can climb to get to platforms that are unreachable. We have the diamonds, of course, that we pick up to increase our score. And we have the little monsters right here that will try to attack us and kill us. But we have the power of Thor's hammer that will crush any enemy in our path. And also we have this little square right here. And if you've noticed in the introduction, of course you've noticed because I've told you like 10 times because I'm so proud of it. This is the camera that will follow our player wherever he goes. So instead of having a huge camera around the entire level and having to move our tiny player around, we make the camera follow our player wherever he goes. That is very cool, and I encourage you to create your own game sketch and see how you want to make your own game. So next thing, let's talk about the 2D platformers, because our game is going to be a 2D platformers. So I'm sure you're familiar with a couple of these. This is a recent game called Celeste, which many regard as one of the best games of, I think, 2017. I'm not sure, but it's a fairly modern game. And as you can see, it's just like our game where it has tiles and it has a pixelated character that moves around in the 2D platform that they have created. Next thing, we have a Hollow Knight. Not sure if you've played this game, but it's really amazing. It's similar to Dark Souls in its difficulty, but it's a 2D platformer. And I've used modern examples just to show you how much 2D platformers are still relevant in game development. And you can see right here that it also has tile maps and platforms and backgrounds and little pixelated, although they are more polished than our game and not as pixelated, but the same concept applies. And finally we have Shovel Knight. I'm not sure if you've played Shovel Knight, but it is an amazing game. I've played it, I finished it, it's very cool. And as you can see, this is very similar to our game. It has the ladders, it has the enemies. Well, the enemies are bigger, and it's pixelated just like our game. And the final example, I found this on Google. I'm not sure who did it, but as you can see, they have sketched up the game and pixelated it, and it shows the tiles that were used to create the game. We will use similar tiles or similar way of tiling our game and making our game a 2D platform just like this one, with ladders, with platforms, and with a background. So, Castle Conquest game design. What am I going to talk about right here? So, this is a screenshot of our game, and let's talk about the core mechanics. So, we'll have our Conqueror running, jumping, climbing, and he will also be attacking. What else should we talk about? The core gameplay. Well, it's going to be getting from the start of the level, from the starting door, to the end without getting hit more than 3 times. As you can see, as you saw in the introduction video, I've showed you that our player, or the Conqueror, he's the player in our game, has only 3 lives. And that's not talking about the lives that he can actually pick up, but every time he gets hit, he loses a life, and if you lose 3 lives, you're done. You need to go back to the main menu. So let's talk about game story also, because that is, you might think that, well, you know what, I don't think we need a game story, and you are completely wrong, because the game story will be the, I'm not gonna say the core, but it is the nucleus around which the core is built. So what is our game story? Well, you are a king and you've just inherited the castle from your father. Monsters, pigs have taken it, and you need to defeat them all, and you need to go through every room and try to crush every single one of them. And also along the way, you'll need to collect the diamonds. So this will make the game much more interesting, and as you're playing through it, you can feel that you have the ability to take charge of whatever is happening in the game, and you have a reason for killing the little pigs, not just for the sake of killing them. You have a reason, and you're collecting diamonds for a reason, because your castle is infested with them and you need to take back your pride. Okay, that's a bit dramatic, but you get the point. You always need a story for your game. Next thing we're going to talk about are the technical requirements to create this game. So as you can see, we had a lot of stuff. So first thing we'll need is a tile set for the background and the foreground with some elements. So I've chosen a tile set that I will show you later on where I got it from, and I will leave it of course in the resources. Feel free to go and get your own tile sets, but make sure that you have a foreground and a background tile set for our game. Next thing, we're going to use inputs from the keyboard to control our game. We will add a follow cam that will follow the player or the Conqueror wherever he goes, and zoom in and out depending on his movement. As you saw in the introduction video, when we're running there is a certain zoom in, when we're standing still or idling there is a certain zoom out, and so on and so forth. And we'll also create an automatic way of adding background to our game. That means that we'll add rules to our tiling and make all the background automatically fill everything and save us a lot of time. So let's talk about some more gameplay features that we'll have. As you can see right here, our little player is punching the air, but even though the pig is a bit far away, but the Conqueror's movement, we've covered this before, but it's going to be running, jumping, and swinging the hammer. As you can see right here depicted in our screenshot, there will be hazards, there will be bombs that burn and explode if we're near, and they can actually kill us. We will have a start and end point. We'll have doors that the Conqueror walks through to get from one room to the next, and by room I mean the levels of our game. Next thing, we'll have the pickups, and the pickups are lives along the way for the player to pick up as we walk, and all the diamonds that you can carry with you. Now it's time for your challenge, and your challenge is going to be to create your own game design. So figure out a story for our game. Think of a compelling story, a story that will make whoever is sitting behind the computer and who's going to play your game feel excited, and give him reason, give him the motivation to go and kill all the pigs and collect all the diamonds. Next thing, you need to find out the game mechanics you want. Maybe you want to add other game mechanics, and I completely encourage you, even if you don't know how to actually implement those mechanics, just write them down, keep them with you, and along the way you will find out how to create them. You will go and download your own sprites and tile set, and as I've told you, make sure that you have the foreground and the background. I will leave the links in the resources for you to go ahead and download or search for whatever tile sets and sprites you want, or you can simply use the same that I'm using. Figure out what features you want to add. So as I've told you, we have picking up things, we have climbing the sheets. You can also add your own features. I'm not sure what those will be, but for example, you can add power-ups. That's a good idea. So write that down also and figure that out for yourself. And as I've told you, this is going to be very exciting. I'm so pumped to start creating this game, and I hope so are you. So let's start our journey together, and I'll see you in the next video. Welcome back, everyone. Now we are starting a new project, which is very exciting. Okay, so first thing, we are going to create our project. So open up your Unity Hub and go into add new. So it will be a 2D project, and we'll name this Castle Conquest 2D. And remember where we're saving it, because we'll need it for the repo. So create, and now we wait for the project to be created. I'll see you in a bit. Welcome back. So I've accelerated the process of creating the Unity project using the magic of editing, and now we are going to set up a new repo. So this is from Magic Cube. To set up a new repo, simply click on the plus button up there. You can close this tab and click on the create button right here. So we browse for our path. So wherever you've saved your path, go into that and click on the Castle Conquest 2D. Select the folder, keep it on Git, keep the create repository on account unchecked for now. Click on create, click on yes, and now we have a repo. So as always, we know that we should simply click on the library, ignore everything beneath library, click on OK. Now we go into the git ignore, double click, open in our notepad, and you should have everything by copying it and pasting. If you don't remember how we did it, check out the I'm not sure which video, I think it's the second video in the previous section, and you'll find where you can get the git ignore, or simply Google it. And now we have everything set up. So we simply going to stage all, commit, and call this initial commit. Click on commit, and we are ready to go. So first thing we're going to do is we're going to be importing the sprites I've provided you in the resources. So go ahead and get them. Simply click on them and drag them into our project right here. Now, before we get started, I want to take a moment and explain what is a sprite. So this is a sprite. This will be our hero or our conqueror. And as you can see, he is a image. So a sprite is a 2D object, and this 2D object has a graphical image on it called texture. So sprites are 2D objects and they have graphical images on them called textures. And they are used by adding a component called sprite renderer to an empty game object. So we create a game object, we add a sprite to it, and we can have a graphical image on it. Okay, so now that we've explained what a sprite is, it's time for us to create our terrain. So, or before even that, it's time for us to slice up our terrain. So right now, if you click on this small arrow right here, you can see that it's a single image. So what we need to do is we need to slice it up. So if we click on it, you can see here in the inspector that we have many options, and one of them is the sprite mode. First thing, you need to make sure that your texture type is of sprite, 2D and UI, and the sprite mode should be multiple. So click on that, apply everything, and go into sprite editor. So as you can see here, we have all of these. So the top ones will be our foreground and the bottom ones will be our background. So here on the top at the left, you can see that we have multiple ways of slicing our sprites. One of them is automatic. So let's try that as an experiment. So if we click on slice, we can see that it slices them up pretty good, but that is not what we need. We don't want this entire block to be a single slice. We want to slice it up into 4 little sprites. And this one also, I think this this one is 9 sprites. This one is 4 little sprites. So how can we do that? Well, actually in slice, we have something that's called grid by cell size or grid by cell count. We'll be using the grid by cell size, and I know that the pixel size should be 32 by 32. So we slice that up, click on slice, and now we have our sprite sheet sliced up into little sprites. Okay, great. And you can click on each one of them and check the information about it. So this is terrain, this is terrain also, and each of them has a number. Now, if you have the time and you want to be very meticulous with this process, you can actually rename each one of them and make it your own, but we don't need that, honestly. Okay, great. So apply that on this button right here, apply that, and now we have our sheet sliced up. Excellent, great. And this is everything we'll need to do, and it's time for a challenge, and your challenge is going to simply be slice up your own sprite sheet. So import whatever sprite you choose to use for your game. I've given you the resources, the website where you can find free game arts, and simply import them, slice them up into sprite sheets for the background and the foreground tiles. Make sure that you have background and foreground. And as a last step of this process, we are simply going to create a folder. We'll call this Sprites, and we'll drag the terrain inside of it. And another thing, maybe we'll change this and name this level 0. Because we don't have any other levels, simply level 0. Okay, so this project will be great. It will have lots of sprites, it will have lots of scripts. So let's start with some good organization habit for the first video. And I'll see you in the next one. Welcome back everyone to another amazing video, and this especially is the best video I think in the whole course, because we are actually creating our platform. As you can see here, we've made a small platform. We have this tile map over here on the right. We have on the left also a tile map grid in our hierarchy. We've used all the sprites that we've sliced before to create this platform right here. So let's not waste any time. I'm so excited for this video. I hope you are too. So I want you to summon all your creative power to this video, and I'll see you in a bit. Okay, so tile maps. What are we going to do? Well, first thing we did is we got our sprite sheets. We sliced them up into little sprite sheets. We are going next to create tile assets. We're going to take those tile assets and add them into our tile palette, and finally we'll use our tile palettes to create our tile map. Okay, great. So back to Unity, where we are going to first of all go to Window and look for our tile palette, which should be under 2D and tile palette. So click on that, and now we have our tile palette. Feel free to dock it wherever you want. I feel like I want to dock it next to the inspector. Make this a little bit bigger because we are going to need it later on. Next step, we go into our hierarchy here on the left, where we don't have anything except for main camera. So right click and go to 2D object and look for tile map. When you click on it, we can see that a grid has been created. It's called the grid in our hierarchy, and a tile map. So let's change the name of this tile map to let's go into inspector. Make sure you go from inspector to tile map. So tile map changes to background, and create another one. So in grid, we're going to create another tile map, and we'll call this one foreground. Okay, great. And we'll also rename this from grid to tile map grid. Everything is great. So now what we're going to do is we're going to create a new tile palette. So go into tile palette, and here under create a new tile palette, click on it, and it will ask you for a name. We'll simply name this main palette. Create, and it will ask you where you want to save it. These are your assets folders. So let's go ahead and create a new folder, call this tiles, and save it inside of our tiles. Select the folder. Now we have a new folder which is tiles, and it has a main tile palette, and this is our tile palette. So what are we going to do now? Go back into our sprites in the hierarchy on the left and choose all of these sprites. So go ahead and choose all of them. To do that more fast, click on the first one, go to the last one, hold shift and click on it. So you choose everything and drag them into our tile palette, and we should have a big huge mess right now. Go back to tiles, and inside of tiles select the folder and save them there. So wait for them to become tile assets, and they should be at now. Okay, so as you can see, a huge mess has been made. Now of course we are going to be moving all of these and rearranging them. Now you can rearrange them the way you want to. I will do it later on. It will be the same arrangement as the one on the terrain. Feel free to do your own arrangement. So now it's time for the exciting part. So let's choose one of these tiles and start drawing. But as you can see, these are very small. So what's the problem? The problem is that when we are choosing our sprites, they are actually, the pixels per unit is 100. So how are we going to make them fit? We're going to change this to 32. So go to our sprite, click on it, go to the inspector, and make sure that the pixel per unit is 32. Apply that, and they fit perfectly into our squares. Great. Back to our tile palette, and now let's go ahead and draw a simple, very simple background. So we can also, let's learn a bit about the stuff up here. So every time you want to draw, you have to make sure on which active tile map you are. So for example, I just drew a bit of tiles which were on the background, which was not correct. You need to make sure you choose the right active tile map. And over that, you can see that we have this brush which allows us to draw a single tile every time. We have next to it this box drawing, which we can simply click on here and drag it and make as many boxes as we'd like. We have this pick where we choose one of these and we can actually change all of them. And now you can also experiment with all of this. And we finally have this what is this? An eraser, where we can remove whatever we feel like removing. So let's draw this again, and now we are going to change into foreground. And now when we are foreground, we choose the tiles for the foreground, back to background, make sure that everything is in the background, and the things in foreground are always the tiles for foreground. So now if we click on play, this will be our game view. How cool is that? We're beginning to create our game. Excellent. But something I want to point out is that we need to make sure that we are working on the right layers. So what do I mean by that? Well, if we go back into scene and our tile palettes, if we click on the background, we can actually draw over our foreground palette tiles, which is not very good. We need to make sure that whenever we draw, our foreground is, well, in the foreground. So how do we do that? We do that using sorting layers. And sorting layers are a very, very cool aspect. So if you go into the hierarchy in background, you can see that we have a tile map. Under it, we have a tile map renderer. Now, if you want to go into the Unity documentation and find out everything about everything, feel free to do that. But what we're going to focus on are these additional settings. So if you have it closed, open it up, and you can see that we have sorting layers and we have order layers. And now on foreground, you can see that we have these sorting layer and order layer. So we need to create a sorting layer for our background. So click on this sorting layer, which is now default, and click on add sorting layer. So to add a sorting layer, simply click on this plus right here, and we'll call this our foreground. Let's add another sorting layer and make this one background. Now we have two sorting layers, and below it and above it we can see the tags, which is something that's useful for coding, and layers below it, which is good for collisions. We'll talk about these later on. So go back into foreground, and now in the sorting layer, instead of default, choose foreground, and for the background, choose background. But as you can see here, our background still is in front of our foreground. Why is that? Well, if we go back into the layers, into the sorting layers, the ones below will be rendered first. So if we move up the background and put it above the foreground will be rendered in front of the background. And every time you need to make sure that you have your layers in the right ascension or descension. Okay, excellent. Save that. And now we are going to create a simple platform, a very simple platform. But first, no, not a challenge, not yet. First, I will use the magic of editing to rearrange all of these tiles in here, and it's not going to be something very amazing. You can do it the way you wish to do it. I'll simply make it the same as our original arrangement. Okay, I'm back from my magical editing trip. So as you can see, I've rearranged all of my tiles, and I forgot to do something. I forgot to teach you how to actually do that. So excuse me. To do that, simply click here on edit. When you click it, you actually have access to all of these tiles. So if you check on here, you can actually select an area of the grid using S, and then you can move it using M. So click on S, click on one of the tiles, click on M, and now you can move it wherever you want. And when you finish editing, simply click on this edit button and it will save for you. So let's change this back, S and M, and save, and Ctrl S to save everything. And now it's time for your challenge. And your challenge is going to be to create your own platform. So create the foreground and background tiles, create a new tile palette, rearrange the tiles in that palette just as I did, or find your own personal way of rearranging them. Create a platform from the foreground with a background. So pause the video right now, rearrange the tiles the way you want them to be rearranged, and then go ahead and create some kind of platform. Don't worry about how much the platform should be amazing or great. This is just for simple training. I'll do it later on, but pause the video right now and try your best. Okay, how did you get on with that? I am so excited to see what your palette would look like. So now I am going to create a small tile just inside of our screen. So if we dock the game right next to it, and it's 16.9, great. So we can see it, but for now let's simply keep it there. And I'm going to create a platform just inside this camera. And to not bore you with all the details, I'm going to again use the magic of editing. It's such a good magic. It's better than Harry Potter's magic. And I'm going to create a grid or map right here. So I'll see you in a bit. Hello and welcome back. So as you can see, I've created a small platform right here, and what this platform consists of is just I made a small, or not small, a rather big wall in here, an obstacle. Maybe I'll make it smaller later on. I made a little platform here where we might put, I don't know, maybe diamonds or a hidden box. Then I made these kind of steps where our player can jump on, and that's basically it. Nothing too fancy. And I hope you did create your own platform, or you might have waited for me to create the platform and then took inspiration from it. But what I want you to do is create your own platform. Don't just copy mine, because this is the best part in the course. It's actually creating levels using the amazing magic of tile maps. A lot of magic in this video, and I'll see you in the next one. Welcome back everyone to a brand new video. In this video we are going to be investing time. Yes, we'll be investing time right now to save ourselves a lot of time later, and we'll do that by creating rules for our tiles. So as you can see, now we can automatically create tiles. So as you can see, they fill up automatically, which is very cool and very helpful. So I'll be teaching you how to create these rules. I'll give you all the resources needed. It will take some time and some understanding to get it, but don't worry about it. Everything will be explained. So I'll see you in a bit. Okay, so first thing we're going to do is we're going to be importing our 2D extras tile map rules. There are two ways to go about this. You can either go into Google and type 2D extras Unity and then go into the first result, which is GitHub, and download it from here. You'll get a zip folder and you simply have to import it. First of all, extract it, and then you simply drag it into your Unity assets, or you can use the one I've provided you in the resources. I will use that right now. So simply take this rule tile that I've provided, drag it into Unity and put it inside of assets. Wait for it to import. It will give you a long list of things to import. Simply click on import right here on the bottom right corner. Wait for it to finish up. And now you should have this folder right here. When you do get this folder, you can go into tiles and you can simply, let's go ahead and put all of these in a single folder. Let's go ahead and call this terrain tiles. Go ahead, choose all of these and simply drag them into terrain tiles to have more space. And now if you right click on your whatever you want, I recommend you go into tiles, go into create, and you can find at the top right here that you have something new. One is a prefab brush and the other is rule tile. So click on rule tile, and for this particular rule set we are going to make rules for our background. So let's go ahead and call this background rule tiling. And now if we click on it and go into the inspector, you can see here that we have some weird structure of windows. So we have the default sprite and we have the tile rules, a list which is empty, and we can add to this list by clicking this plus button right here, and we can add rules. First thing you'll need to do is dock this inspector. So simply go up to the upper right of your screen and click on this little lock here, and now this will not change. This will be very helpful. So now as you can see, it tells us that there are none sprite. So we need to add a default sprite, and because we are working on the background, we'll be only working on the background sprites. So go ahead and add whatever random sprite you want to be the default. And now we are going to start by creating our tiling rules. So the first rule will be for a tile which should be in the middle, just like this one, which doesn't have any sides to it, or neither does it have any little, I'm not sure what those are called. These are for the corners, by the way, and this will become all clear just in a bit. So now we've created our first rule. Congratulations. Let's go ahead and add it to our tile palette. So you can either create a new tile palette simply just for our rules, or you can add it right here up there above all the default tiles. I'll add it into this one because it's more practical, I believe. So simply click on this background and drag it into our tile palette, and it should show right here. So now if we click on this one, we can actually draw these rule tiles. See that? Okay, great. And as you can see, all of them are of the same type. But if we choose to create rules for it, so for example, if we click on this one, as you can see, everything changes. Why is that? Well, let me explain how these rules actually work. So let's see this in 3x3 box right here. And if we can actually add these kind of arrows, and as you can see, the more we add, the more it changes. And what these mean is the green arrow means that there is a tile above it. So when there is tile above it, to the left of it, to the right of it, and below it, then we can draw this tile. So this is a rule. And if we click on this green arrow again, we can see that it becomes a red X. And what this red X means that it will only draw when there is nothing to its right. And we can see here, oh, and if we actually click here, it actually makes, well, it shows us what will happen if we add a tile here. And you might be wondering, why are all the other tiles this way? Well, because it's our default sprite. So let's go ahead and add another rule, and let's keep this like this, because actually this is our rule for this particular tile. So let's go ahead and add another rule, and for this rule, let's go back into sprites. We'll add a corner on the right side. So let's go ahead. So what do you think the right side should have as its rules? Well, I think it should have one below it, one to its right, and one on its diagonal, and it shouldn't have anything on either side. Now, nothing changed pretty much, but that's okay, because we'll add another rule. And for this rule, let's see what we have. Let's add this one. Oh, and in this case, if we have something on these sides and nothing on that side, we should have this right here, and it's pretty much correct. Now, so let's go ahead, create another rule and add this one to it. So now if we have, for example, what should this have? If it doesn't have anything to its right and it has something on its left, it should create this one. Another thing about these rules right here is that you can actually change them, and they can be either rotated or mirrored on the X or Y axis. What does that mean? Well, if we click on this one, you can see that it rotates all the rules. So if we don't want to create rules, for example, we want to make a rule that's like this one, okay, we can simply click on the mirror on the X axis, and it will create that rule for us. But we won't be needing that because our assets are rich and they have everything in them. So now I'm going to create a set of rules. Let's simply delete that one because we don't need it. I'm going to create a set of rules, and before I do that, I'm going to issue you a challenge, and your challenge is going to set up your own rules, because I believe even that you can create better rules than me for the background. So first thing is import the 2D extras file I've provided in the resources. Then you have to set up your rules for automatic tiling and use the rules to paint your own platform. So go ahead and try your best, and if you feel that you can't even come up with the simplest rules, I have provided in the resources also the rules. I've screenshotted everything beforehand, so I'll see you in a bit. Okay, welcome back. So how did you get on with that? I hope you at least tried to create some rules. So let me show you what I've done. So I have created, I think it's about 17 rules, and the way I did them, I actually started looking at different ways that each tile might work and how it should be positioned. And of course, if you don't have any idea how to create the rules, I've provided you some pictures or screenshots that I've made, so you can copy them and use my tiles. But remember, mine are not perfect by any means, and I left out a lot of tiles because it's a very exhaustive list. I want to create an example for you to create your own rules. It will not be easy, it will not be done in 10 minutes. I think this actually took me I think about maybe 2.5 hours to finish all of them and test them and make sure all of them work. So to demonstrate how the automatic tiling works, let's go ahead and choose to erase a couple of them. So as you can see, when we erase them, new tiles are created to wrap around, and as you can see, we have a mistake right here. and there might be a lot of other mistakes, but some of them work, like this one for example works perfectly fine. So let's go ahead and delete all of these and delete all of these, and let's try them out in our platform and see how they work. So let's go ahead and click on this, choose the automatic tiles, and let's remember to always have it on background. So let's create something right here, and then we'll create something right here, and as you can see they fill up automatically and it's perfect, I guess. Let's see if, oh, there is something right here. I think we need to create another rule for that. I believe it's the one where you have only 2 on each side. So let's see. Okay, so let's go ahead and create a new rule and let's see which one we should use. So we want to cover this area right here at the top and one over here. So we'll choose which one. Okay, this one. So let's drag it in here. As you can see, it fills up automatically, but that's not what we want. We want to actually create a rule for it to always follow, because that will always default to this one. So it doesn't have a tile to its upper left, it doesn't have a tile to its bottom right, and it has tiles to both sides and tiles to above it and below it and on either side. Excellent. So now you can see that we have our rule set up right here. We can automatically tile all the background. It makes our platform much more aesthetic than having all of them the same. You can create also a rule for your foreground tiles. I tried it, it's meticulous, it takes time, and I encourage you to try and create that also. It will make your life 20 times easier. I hope you enjoyed the video. I hope you're excited as I am about this. In the next video, I think we'll be finally adding our player, or our Conqueror as we'll be calling him, our Conqueror. So I'll see you in the next video. Welcome back, my fellow game developers. As you can see, finally we've created a player, and this player is our Conqueror. We'll call him Jimmy. So Jimmy right now doesn't do anything, but if we click on play, we can see that our Jimmy Conqueror actually has an idling animation that's running right here below. I'll teach you everything that we've done. You'll have a big challenge, so I want you to give me your entire concentration force, and I'll see you in a bit. Okay, so first thing we're going to do is we're going to undock this, and we're going to delete all the unnecessary things we have up here. So let's go ahead and delete all of that, zoom back in, go to our inspector, save that. Then let's go and create an empty game object and make this smaller. We don't need it that big. Click on that to remove, make it a little bit bigger, and we'll call this game object our player. And this player will be reset to the middle of our screen. And honestly, this is the most exciting part of all game creation, when you start making your player. So let's go over some technical words. Animation 101. First thing you'll need to learn is an animator controller. So an animator controller allows you to arrange and maintain a set of animation clips. You'll see what that is in a bit. An animator component used to assign animation to a game object in your scene. So if you have a game object and you want it to have animations, you assign it an animator component, and that animator component gets an animator controller. It's a bit confusing, we'll see everything. Animations, it's several sprites rendered one after the other. So it's a set of sprites, one after the other. We put them next, just like video works, where it's a set of images one after the other. And finally, a sprite renderer, we've talked about it previously, renders a sprite for 2D graphics. Okay, great. So back to Unity. And from Unity, we are going to be importing the sprites I've left you in their resources for our human. So let's go ahead and go there. And here you can find that we have fall, idle, jump, and run. So we'll use for now idle animation, but in order to create the other animations, we have the run and fall, jump. So click on the idle and drag it into our Unity. So we have it right here. Actually, we want it inside of sprites. So let's close that. And now let's create a folder. First for our Conqueror, we'll call this Conqueror. And our Conqueror will have this sprite. First thing we're going to do is we're going to be slicing up our Conqueror. But before we do that, I want you to understand the steps that we are going to take. So we are going to import the Conqueror sprite sheet and slice them up. We're going to create the player object. We've already done that, and add a sprite renderer to it. We'll do that right now. We'll create an idle animation. We'll add an animator to our player. We'll create a player animator in order to add all the animations to it. We'll add an idle animation to the animator, and we'll assign the animator to our player. So let's go ahead and do all of those things. First thing, let's slice up our player. So we'll go to multiple, we'll make the pixels per unit 32, and we'll apply all of that. We'll go into our sprite editor. So as you can see here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 sprites, and they are spread over 800. Here below you can see it, 858 by 58. If we do automatic slicing, you can see that it does the job pretty well, but the problem is that when we'll be adding other animations to our Conqueror, we'll have a slight problem with that. That's why I'm going to slice it up in a manual way, and it's going to be 58 by 58. We slice that up, and as you can see, it's not very accurate. Why is that? Because we want to have some kind of offset. Why we need that offset? Well, because 58 by 58 just doesn't cut it. And we're going to pad, let's do a padding of, an offset of 20. Nope, I meant padding. So padding of 20. And now we can see that they are all in the middle. The most important thing is to have our Conqueror in the middle of the sprite. So all of them are in the middle. And okay, great. So slice that up, apply everything. You can, as always, I've told you, you can rename them if you want to go down that road. So we've sliced up our sprites. Now it's time to add our renderer. The way we do that is we'll move this up here, and we'll add a component, and it's going to be a sprite renderer. And in our sprite renderer, we have this default sprite. Choose anyone you'd like and put it inside of it, and we have our player. Great. So now what we need to do is we'll need to add an animator to that player, or actually an animator component that we've talked about. So let's do that. Simply type in animator. Now we have an animator controller, and this object can now begin to have animations. Back into assets, let's create a folder. We'll call this folder animations, and inside of animations we are going to create an animator. So animator controller, and we'll call this the player. Now let's get back. What should we do right now? Okay, so next step is going to be, we're going to open up our window for an animation. So go into animation and click on the animator window, animations, animator, and we have the animator, but we are going to dock it in a different way. Feel free to dock it however you want. This is my personal style, so I'll dock the project and console next to each other, and I will dock the animator. Wait, what? And I'll dock the animator right here below. Okay, need to do a couple of restructuring right here, just like that, and it's perfect. So this is our animator right here below our scene, and we'll add also a window for the animations. So animations, and we'll dock it next to the animator, just like that. Okay, great. Next thing we're going to do is we're going to create an animation, and we'll be adding it to our animator. So as you can see, we already have a couple of states. These are called states. This is the entry state, this is from any state, and this one right here is an exit state. So let's create an animation, the best part of our game. So go back to Sprites, Conqueror, and the way we create animations is we choose all the sprites that we want. So as I've told you before, click on the first one, go to the last one, hold shift, click on them. You've chosen all of them. Right click on it and go to create and go down into animation. So this will create an animation. And we'll call this idling. Idling. Okay, great. Now we have an animation of idling for our player. Simply drag that into animation, and inside of animation we have to now add this idling animation to the animator. So we do that by simply click on the idling and drag it into the animator, and now we have an idling animation for our player. One thing we also have to make sure of is we click on animation and add a loop time, because if we don't, he'll do this animation once and then stop. But idling is an animation that we want to have over and over and over and over. So click on that, save all of this, and don't forget to go to player, and in the animator controller it will ask you for a controller. You can either drag this here, or you can click on the little circle and add the player animator. Save that, and now let's click on play and see what we've done, or if anything works at all. So if we go back to scene, we can see that our player moves and he is idling. Whoop, whoop. Okay, great. Very exciting. It is very exciting, but there is a problem. If we take our player right now and drag them into our platform, we cannot see anything. So where is he? What's the problem? The problem is, well, it's actually your problem, because see what I did there? I actually changed the steps into a challenge, because maybe you're just watching and not doing anything. So this is your chance to do the challenge. So your challenge is to do all of the things that we've done already. You can rewatch it. Maybe you already doing everything with me and pausing the video, but if you're not, now is the time. And your extra challenge is to use the sorting layers to make our player visible in front of the background. So we've covered sorting layers before. I think you have enough skill to do all of them, and I'll see you in a bit. Welcome back. I hope you did your best in that challenge. I hope you just didn't stare at the screen. So we'll choose player. We'll go into Sprite renderer, and we see here that we have the sorting layer just as we had for the foreground and background. So if we click on default, we don't have a player, and we can add a sorting layer. So let's go ahead and do that. So a new layer, we'll call this the player layer. Player layer, that's fun to say. And we'll put it in front of background and behind foreground, even though he will not be going over the foreground or behind it, but we'll render it that way. Save all of that, back to player, and choose the sorting layer to be the player. So now our player is on the player layer. Say that 10 times. And now I think that our player is just a little bit small. I think we'll make him bigger. So let's go into sprites, and the way we do that, we choose the Conqueror sprites, and we'll make this 30. So if we make this 30, click on apply, he becomes just a little bit bigger, just so he can be seen better. And if this camera logo in here is bothering you, it's bothering me, you can actually click up here on the gizmos and you can make all the icons smaller. You can even make them disappear. Okay, great. So I hope you got on with that challenge. I hope you are excited as I am, because our player is actually moving and we have breathed some life into our game. I'll see you in the next one. Hey there, this is Michelle from the future. Sorry to interrupt, but I want you to do something that we haven't been doing so far, and that is committing our changes. Maybe you've been doing that and I congratulate you, but if you're not, this is a great time to start doing so. As you can see, I've been doing it each video. So slicing up sheets, creating tire palettes, created a platform, added rules, and now we're going to add the animation. So we'll commit that change and adding animation or adding idling animations. So if you haven't been doing the repos right here, this is a great time to start, because we are going to be doing a lot of things in the upcoming videos. So I'll see you. Welcome back, my fellow game developers, to a brand new video. And this one is very exciting because we're going to be learning about other animations and even more transitions. So as you can see here in our animator, we've added two new states, which are climbing and running, and we've added transitions between them. We've also added parameters that will allow us to make those transitions. And now if we click on play, we can actually take our player from the idling animation into the running animation, and we also make a climbing animation from what we have. So I'm very excited for this video. I hope you are too. So let's get into it. Okay, first thing we'll do is we'll go and add the sprites for running and the climbing. So for the running, we have this run sprites, and for the climbing, I'm going to use the fall and the jump because we don't have the actual climbing animations, but I wanted to include that in our project. So go ahead, click on all of those and drag them into our Unity. So we have jump, we have the idle, the run, and the fall. For now, let's just focus on the running. So as you know, this is a step that we've done multiple times. Let's go ahead and click on run, make it multiple, make the pixel size 30, because as you remember, we've increased the size a bit. Save that, and yes, I meant to apply. Go back to run, and for some reason, okay, so go into sprite editor, and we have those sprites. Let's go to grid by cell size. It should be 58 by 58 with a padding of 20, as I remember. Yes, exactly. Okay, so apply that. Now we have our sprites. Let's go ahead and click on all of them as we did before. Check all of them, right click, go to create animation, and we'll call this running. So running, great. Close that, take running into animations, and later on we'll create a folder. So now let's add the running animation state to our animator. So add running right there. So now this is a bit tricky, but let's zoom in, move that exit to over here, and now we have the idling and the running next to each other. So how are we going to tell our animator that we want to transition from the idling into the running? Well, if you right click on idling, you can actually make a transition. So make that transition and push the arrow into the running. And if you click on that transition, as you can see, we have lots of options and lots of settings also. So let me tell you just a bit here. let's talk about transitions. We have a bit of blending here between the animations, but we don't want that. So as you can see, we have this blending right about here, and we can actually remove all that blending so it goes immediately from idling to running. And we'll do that because we already have very good 2D animations, so we can simply go into transition, duration, and put it to 0. That way there will be no lag between animations. So now we have the idling going to running, but how is it going to know that we actually want to go down that road? Well, we do that using the parameters here on the left. So go from layers into parameters, and as you can see, we have an empty list. So here is where we start adding parameters, and we can add a couple of parameters. We can add a float, an integer, a boolean, or a trigger. For now, we'll be using a boolean, and that boolean will be called running. So if we want to transition into running, we'll need to use the running boolean. And in order to add it, if we click back on transitions, we have the conditions right here. And this condition list is empty. So we click on plus, and it automatically adds the running because we don't have anything else to add. And now if we click on play, we can see that we are right now in the idling, and if we click on this boolean, we go into the running, but it does it only once. Why is that? I'll give you a mini challenge right now to figure it out. Okay, enough. So let's see, running should be in a loop. Save that, back into play. And now if we click on the boolean, he starts running and he keeps running forever. Why is that? We want to make this better. So we'll add a transition back from running to idling, and this transition will also have a duration of 0, and its condition right here will be running, but when it's turned to false. Save that again, click on play, and now our player is idling, and now he's running, and now he's not running, and now he's running, and now he's not running. Okay, so this is very cool, this is very exciting, and this is a great time for your challenge. So your challenge is to create the climbing animation. So import the climbing sprites from resources, slice them up and size them appropriately, create a transition from idling into running, and finally create a trigger for the transition. So pause the video right now. I've given you all the steps that you need. I want you to try your best. So I'll see you in a bit. Welcome back. So how did you get on with that? Let's go ahead and do the challenge. So first thing we'll do is we'll go into our Conqueror sprite, and as I've told you, we'll be using the fall and the jump animation in order to create our animation. So this will be a bit tricky, and now we'll go into our fall. So our fall should be 32, and we'll make it multiple, even though we don't need to do that, but because we're going to slice it up our way, so it's 58 by 58. Apply. We only have one sprite, and in here also we have only one sprite. So apply that. Don't forget to make it 30, not 32. So 58 by 58, sliced it up, apply. Great. So now we are ready to use these two. So let's click on those, right click, and create an animation, and we'll call this climbing. So climbing animation, back into our animation folder, and we'll add it into our animator. We'll create a transition from idling to climbing and a transition from climbing to idling. We'll also turn off all the transition duration on both of them, and we'll create a new parameter which will be a boolean, and we'll call this climbing. So climbing. And now we'll add this condition to from idling to climbing. The climbing should be true, and from climbing to idling, the climbing should be false. Save that, click on play. Did we put it into loop? I'm not sure. Let's try it. So climbing, and it stops because we haven't put it into looping. Save that again, and now if we click on climbing, he starts climbing, but as you can see, it's kind of super fast. So let's go ahead and play around with our animation. How do we do that? So we have an animation tab right here that we haven't used yet. So go from animator to animation. And as you can see here, we have this climbing. If we click on player up in the hierarchy, we have the idling, we have the running, and we have the climbing. And if you click on any one of those, for example, idling, you can see that it tells us which things change during the animation. For example, here, the thing that is changing is the sprite. So we can actually take it frame by frame or play it right here, and we can see that our player moves with the idling, and you can see every single frame in it, and you can go forward and backwards, make it smaller, make it bigger. So we'll use that for the climbing. Why is that? Because as you saw, the climbing is extremely fast and we want to slow it down just a little bit. So how are we going to do that? Well, it goes from here to here, so we'll add another one. So copy that, click on Ctrl C, go to the frame in where you want to put this sprite, and Ctrl V. Okay, so now we have these two. Well, actually, let's choose both of these and Ctrl C, Ctrl V, and then again. So it's 3 times. Let's make it 1 second. Okay, let's see how that works. Click on play. It's a bit fast still, but at least he does it multiple times. We can actually, let's take them apart. If we choose all of these, and let's, you know what, let's delete the last 2 and choose all of these, and we actually can spread them out over a second. And now if we click on play, it will be just a little bit, something is wrong, right? Why is that? Because the last frame, well, actually they're not spread out correctly, so let's spread them out correctly. So this is on 4, 6, 8 on the 1, and the last frame should be the same as the first frame. So let's put in that one, and now if we click on play, it should be very, very smooth. So a final step before we go, I want to go into player, I want to go into the animator actually, and I want to remove the exit time. As you can see, we have something in here that's called exit time, and this is used when you want to transition back into the previous animation or go into the next animation after a certain time. And we don't want this right now, we'll be using it in the future. So go into every single transition and remove the exit time. And we are done. So let's save that, let's click on play and see what we have. So we have our player idling, and if we click on running, he starts running, and we unclick on off running, he stops, and he also climbs. How cool is that? Seriously, this is the coolest part, and I hope you enjoyed the video. I hope you learned a lot, and don't forget to save in the repo, and I'll see you in the next video. Welcome back everyone. Just wanted to remind you of the amazing job you've been doing so far. In this video, we'll be adding a rigid body and a collider to our player. We'll also be adding collisions to our environment, as you can see here, that will make or enable our player to land on the surface of our foreground. So now, if we click on play, our player actually stands on the surface. So let's get started. Okay, so let's start off by adding a rigid body to our player. But before we do that, I think it's a great time for us to prefab our player. So to do that, let's go into our assets, right click and create a folder, and we'll name this folder Prefabs. Let's go ahead and prefab our player. So now we have a player prefab, which feels good. So back to our player, let's go ahead and add a rigid body to our player. So rigid body 2D, and we'll make sure that we have it as dynamic. Save that and apply it to our prefab. The way we do that is we go to overrides, click on down, and there will be an apply all. Okay, great. Before we continue, I wanted to take a second and talk about rigid bodies 2D one more time. So it's a component added to a game object that subjects it to, which should not be TP, it should be to physics engine forces. And we have many body types of rigid body 2D. So we have dynamic, which has finite mass and is affected by gravity and other forces. We have kinematic that isn't affected by gravity and other forces. And we have static, which behaves like an immovable object. Okay, great. So now back into Unity, and because we have a rigid body, now if we click on play, our player falls through the ground. Okay, not very helpful, but it's a step forward. So now it's time for your challenge. It's a bit of an early challenge, but I think you have it covered. So we've talked about collisions before, so now it's time to add the appropriate collider to your player. You need to add a collision to the environment, and you have to make sure that your player lands on platform without falling through. So pause the video right now if you feel that you have the skills to do that. If not, wait a couple of seconds and I'll be right with you. Okay, so colliders, they are very helpful. So go into player, let's close down this rigid body, and let's go ahead and add a collider. So I think we'll be adding a box collider 2D to our player. And as you can see, our box collider is a bit too big for our player, so we'll go ahead and shrink it down. And you can do this however you want. It depends on your preference to the game, how much you want to make the box collider big or small. But what you need to keep in mind is that his feet should be touching the bottom of the collider. So let's make it this big, and this is simply based on your preferences. I like to keep it just smaller than his actual size to make the game a little bit fair. So if you make the box collider bigger, that will make the game a little bit more difficult, and if you make it smaller, it will make it easier for your players. So I think this is good enough, so save that, and as always go to override and apply it to the prefab. So now if we click on play, our player still falls through. Why is that? Well, because we don't have any colliders on our foreground. So let's go and add some. So we'll go into foreground, and if you got to this point and couldn't continue, don't worry about it, because this is something new. We'll be adding a tile map collider. So let's go into tile map, and as you can see, all of the foreground tiles have now a collider on them. But the problem is that if you zoom in, you can see, or you can't, but if you zoom a lot, you can see that there is a tiny gap between the colliders, and believe it or not, this will cause problem for us later on, especially if the player is moving or dropping down at a very fast velocity. He can go through these colliders. So how are we going to fix that? Well, there is a small solution that is called a composite collider 2D. So let's see what that does. So composite collider 2D. When we add that, it automatically adds a rigid body to our foreground. And what this does, it actually, let's close this, and if we click here, if we look into our tilemap collider, we can see that we have a checkbox that is called used by composite. And what this does, if we click on it, you can see that all of the colliders are now on a single collider, but we can't see it. Let's make this bigger. Okay, so now you can see that we have a single line of collision to our foreground. So now if we save that, oh, and there is one more problem. Well, you should have thought of it. Maybe you didn't, that's okay. I've missed it a lot of times. Because we have a rigid body on our foreground, if we keep it on dynamic, all of the world will be falling down. So we need to change this from dynamic into static. That way it stays in its place, whatever happens. So save that, click on play, and now our player stands on our foreground. Now the game is becoming more and more realistic. So this is great. This is a very big leap forward. But there is one other problem, because if we click on our player and we set him here on the edge and click on play, we can see that he actually falls on his head, and now the animation is played. Well, it is kind of cool, you know, but we don't want that. So in order to avoid this type of behavior from our player, we can actually go into our not rigid body, excuse me, we can go into into our rigid body, and down here we can see that we have something called constraints. So this constrains the movement of our player on certain rotations, for certain rotations. So what we want is to freeze the rotation on the Z axis. If you look here at the top of the transform, if we use the Z rotation, our player rotates. So this is the one that will be freezing. Okay, great. Is it still freezed? Do we need it to override apply all? And now let's close that. Why is it telling me that I need to change my collider? Okay, click on play, and now our player stands using his hammer. It's not very realistic, but it's a 2D platformer and it's okay. We don't need it to be very realistic. So I hope you enjoyed the video. I hope you try to do the challenge, and I'll see you in the next one. Hey, congratulations on making it this far. You are doing extremely well. I'm not there sitting with you, but I'm pretty sure if you got to this part, you are doing extremely well. So I hope you're enjoying. Keep on going. We still have a lot to learn. So see you in just a bit. Welcome back to another video and the start of a new chapter in our game development journey. In this video, we are going to start moving our player based on keyboard input. We'll be using the same formula as we did for the previous project or for the Magic Game Cube, but with a different twist to it that we'll see in a bit. So as you can see, we press on the right arrow, he moves right. We press on the left arrow, he moves left. And I'll see you in a bit. Okay, so as the title suggests, we want to manipulate our game object's behavior. So what does that need? Well, that needs a script. And that means coding, which is very exciting and a bit scary. So let's go ahead and add a script to our player. Where is our player? We already have him. So let's go to add component and create a script that we will call simply player. Down here we have new script, and we'll create and add a player script. Wait for it to understand what is happening. And okay, so let's start by creating a folder, one of my personal favorite things to do, apparently. So scripts, and we'll add the player into our scripts. Great. Let's double click on that. And let's wait for Visual Studio to open up and understand everything. Okay, so I wanted to initially do the challenge later on, but I think I'll do it just now. So if you are ready, you can take the initiative and move your player. First thing you'll need to do is import a cross-platform input asset package that I've provided you in the resources. Then you create a run method that is called from inside of update. Then inside of run, use the rigid body to move the player. And finally, add a variable to control our speed. So it's a bit of a daunting task. If you think you have enough skills to do it, go ahead and pause the video and try it. If not, and you think it's too big of a mountain to climb, wait for me, I will do it in front of you. And one more thing, if at any point you feel that you can continue it alone, I recommend that you pause the video and you do it. So I'll see you in just a bit. Okay, welcome back. So maybe you've tried to add the cross-platform input from the resources I provided you, but you can also go into Unity's asset store and search for standard assets, which has the cross-platform input inside. What is cross-platform input? Well, it's something that we'll be using instead of input, and it literally does what it says. What name it is? Well, it's cross-platform input. That means it's across multiple platforms. So this game that we are creating right now could be on a computer, on a PC, or maybe it can be on a PlayStation 5 that's coming out recently. But of course, like this isn't going to be a PlayStation 5 games, but who knows, maybe you could create a PlayStation 5 from this simple graphics. Anyways, let's go ahead and import the cross-platform package. So simply go into the resources and drag the cross-platform package into our assets. It will ask you, do you want to import all of these? Simply click, oh, what is this? Okay, don't worry about that. We've already imported that. And what we do need is the standard assets. So go ahead, look for cross-platform, click on that, and now simply click on import. We only need the cross-platform assets, and if you've downloaded the standard assets from the internet, also only choose the cross-platform. There's no bad thing to do, well, if you import everything, but for now we just need the cross-platform. So wait for that to import, and now we should have a folder that is called the cross-platform folder, and let's go ahead and add the 2D extras, which is under the file 7.15 whatever, into our standard asset to make everything a bit more cohesive, as I'd like to say. Save that. Let's go back into Visual Studio, and because there is a file modification detected, it will ask you for a reload. Simply reload again. It shouldn't do it anymore. Everything is fine. Okay, so first thing we are going to do will be adding using cross-platform. That means at the top here, I'm not sure I've explained this enough. These are the libraries that we are using. For example, the Unity engine is the library for the start and the update and all other Unity related things that we use in our script. So now we have to import the cross-platform library, and we do that by typing using Unity standard assets dot cross-platform inputs. So now we have access to the cross-platform input. Next thing we're going to do is we're going to create a run method. This will be a private method. It will not return anything. That means it's a void, and it will be called run. And what should we do inside of run? Well, we're going to use the getAxis method and get the horizontal. So, well, first thing we're going to do is we're going to put it inside of a variable. So it's going to be a float. It's going to be, let's call this control throw. And it's going to be using, instead of input, we'll use cross-platform input manager. It's a big word, but it's what we use instead of input. It's going to use .getAxis. Now, inside of getAxis, we'll need the string name for our inputs. And where will we get that? Well, let's go back into Unity here. And if we go to Edit, and we look for project settings, we can see that we have our input manager that opens up, and if you don't have it opened up, simply click on input manager. So this is where we have our project settings. There are a lot of things in here. We don't need to go over all of them. So for example, we have physics 2D, which we'll be using very soon. But for now, let's focus on input manager. We have these axes here. And if we click on that, we can see that we have a lot of options. So, and one of them is the horizontal. So horizontal is when we click on the A or D, and this is exactly what we need. So because in here the getAxis needs a string reference, we'll go back into the input manager, and every time we have a string reference, we always go and copy it. We never assume that we've written it correctly, because we never do, and we cannot find the error. So we have a control throw. And why did we use a float variable to catch this input? Because I will demonstrate it. So if we click here, print, and let's go, where is it? Control throw. Let's print that out and see what happens. And let's not forget to call it in the update method. So save that, back into Unity. Let's dock this here next to our tile palette. That's, I think, is a good place. And now if we click on the play and we click on the left arrow, you can see that it slowly goes from 0 to -1 and then back to almost 0. And if we click on the right arrow, it goes from 0 slowly to 1, and that's why we need to save it inside of a variable to always have control over it. So now that we have it, let's delete this print right here. It was only to demonstrate how this works. Next thing we're going to do is we're going to create a player velocity of vector type 2. So we'll do that by first getting the rigid body. So let's create a variable right here that is the rigid body. So it's a rigid body 2D. We'll call it my rigid body 2D. And previously we called this a public variable and we've added it from the inspector. But now I'm going to teach you a much better and maybe more efficient way to do that in code. So the way we're going to do that is in start, we're going to call our variable and we're going to assign to it the rigid body that is currently sitting on our player game object. So we'll use get component, which gets a certain component. And what that component is, well, it's a rigid body 2D. And that is how it's written. Now we have a reference to our rigid body 2D. And let's go ahead and change it in run. So we'll click on here. It's my rigid body 2D. No, before that, let's create a variable for our player's velocity. And that variable is going to be a vector 2. We'll call this player velocity. And this player velocity will be equal to a new vector 2, and we are moving this in the horizontal axis, so we will only be changing the velocity in the x or horizontal direction. So this will add the control throw to the x axis, and for the y we'll simply keep it as my rigid body dot velocity dot y. So in the y direction the velocity will not change, and finally we'll assign the my rigid body to the dot velocity will be equal to the player velocity that we've currently created. So save that. Let's go back into Unity and see if we did anything correctly. So click on here, our player falls. If we move left, he slowly moves to the left, and if we move right, he also slowly, very slowly moves to the right. Okay, excellent. As you've seen, he moves very slowly, and we'll need to fix that. And in order to do that, we are going to create here a variable for the run speed. So let's go ahead and create something we call a serialized field. Ooh, very scary. Some fancy words you're using, Michelle, huh? Don't worry, I will explain what that is. And serialized field is just like public, where we can change the variable from our inspector, but the only difference is that we can actually manipulate that variable from a different script. Okay, so like we use public functions to change, well, to use functions from different scripts, we can actually use serialized field to change variables. And I don't think we'll be using it too much, but let's say, for example, you want to change your player speed, for example, depending on the platform you're standing on, you can go ahead and do that using the serialized field. Okay, small explanation. Let's continue. We're going to make this run speed a float, and we'll call this simply run speed. And what should this run speed be? We can actually do something. Let's try 10f, and we are going to multiply it with the control throw right here. So run speed, oh, not run, actually it's run speed. And now if we go back into Unity and click on inspector and click on player, now we can see that we have a run speed of 10. So we go into play mode. We can move now with a speed of 10, and we can actually increase this to 100. See what happens. And our player, what did you see? Did you see what just happened? Did you see how our player disappeared? Or actually you can still see him right here in the bottom left corner. Don't worry about that. We'll see a couple of more instances of this, but we'll be fixing it later on in the other videos. So I hope you enjoyed. This is the part where our player comes to life and we start manipulating him using code, and everything is fun, everything is very cool. I hope you enjoyed, and I'll see you in the next video. Welcome back, everyone. Our player now moves in the game. But the problem is that he does a moonwalk. So whenever we are moving backwards, he does not flip, he simply does a moonwalk. And we don't want that. In this video, we are going to be flipping our player. So if we click on play, we can see that whenever we move to the right, we move right. But when we start moving to the left, we actually flip our player, and now he moves in the direction and actually looks in the direction he's moving, the correct one. So very exciting. Let's not waste any time and let's jump in and get started. Okay, so how are we going to flip our player in the direction that he is moving? First thing we're going to do is we're going to apply all of our changes to the prefab. So if we look closely at our player, we can see that he moves left and right, but he does not flip. How are we going to go about this? If you go up into our transform, you can see that we have position, rotation, and scale. So scale, if we increase the scale of our player in the X direction, you can see that he gets bigger and bigger and flatter and flatter. But if we reduce it to 0.3, he gets smaller. But what happens if we go beyond the 0, if we go to minus territory, we can see that our player flips. So at -1, our player is facing the other direction, and this is what we are going to be doing, but in our code, depending on the direction our player is heading in. And we'll do that using math, but not very hard math. If you don't like math, it will be simple math. Okay, so now let's go into our Visual Studio and let's go ahead and create a function that we'll call private void flip sprite script sprite. So we have flip sprite and we are ready to go. So flip sprite. Before we start, I need to explain two concepts. First of all, math.abs. So I hope you remember from school what absolute value means. It means it returns the absolute value of something. So for example, if we have math.abs -4, it returns 4. And math.sign. So what is math.sign? It returns the sign of a certain number. That means if we have math.sign -4, we have -1 as a result. And if we have math.sign 4, we have +1 as a result. So this is a quick overview of first grade math or something like that. Let's go back and let's go ahead and create a boolean. So I meant into Visual Studio. So in this, we are going to create a boolean which will tell us if our player is actually moving. So let's go ahead and create a bool which will be running horizontally. Not sure if horizontally takes 2 L's or just one, or actually horizon. The A is not in the right place. Okay, so horizontally equals math dot absolute value my rigid body to the dot velocity dot x. Now you might be wondering, why are we even using the absolute value of our rigid body's velocity? Well, because when we are moving in the left direction, our velocity is negative. And when we are moving in the right direction, our velocity is positive. So we need to take the absolute value to make sure that we always know when our player is moving. And to make this boolean, because right now it's not boolean, we're going to check if it's bigger than, wait for it, math f dot epsilon. Okay, now again, Michelle, you're using very scary words. What is math.epsilon? So first of all, when we type math.f, that means we are accessing the library of math, where we have a lot of functions and a lot of methods to use. And epsilon is not a method, nor is it a function. It's a small number, a very, very, very small number, like say for 0 and 4 or 5 zeros after it and 1. So why are we using math.epsilon? Why not simply compare it with velocity equals 0? If you remember in the previous video when we tried to print the control throw, if you remember, whenever we went to the left, it slowly moved from 0 to -1, and then it went back to -0.00009. It never went back to absolute 0. That's why we are using math f.epsilon instead of simply using 0. Next thing we're going to do is we're going to use an if condition. So if running horizontally, and inside this if condition, I'm going to issue you a challenge. And your challenge is to complete the if statement. So we are going to flip our player sprite based on the direction they are moving. And I'll give you a couple of hints. One, we'll use transform.local scale, and that's how you access the scale of a game object. And you will be using use mathf.sign to determine the direction in which our player is moving. So pause the video right now, give it your full concentration, your full thinking ability, and do the challenge. I'll see you in a bit. Okay, welcome back. So what should we write inside of our if condition? So it's transform, because we need access to our transforms, local scale, and this local scale in fact is a vector 2 because it's 2D, so we'll be using the scale on the x and y. So it's a new vector 2, and what should be right for the x? And the y scale should stay the same, that means it's going to be 1f. Okay, but what should the x be? Well, the x will be dependent on the direction. So we're going to write mathf dot sign, because it depends on the sign of the direction. And what direction is that? It's my rigid body dot velocity dot x. So now save that. So now if our player is moving to the right, the velocity will be positive and the sign will be positive. Our scale will stay 1. But if the player's velocity is to the left, that means the velocity is negative. That means the sign is -1, and that means that our local scale x will be -1. So let's see if that works. Save that, and a small mini challenge I'm going to give you right now. Where do we actually use this flip sprite? Where should we put it inside of our code to flip our player? I'll give you a second to think about it. 1 Mississippi, 2 Mississippi, 3 Mississippi. Okay, time's up. It's inside of run because we'll only be using the flip sprite whenever we are running. Save that, go back into Unity. Let's move out of the camera, click on play, and now if we move right, we move right. If we click on the left arrow, we actually flip, and how cool is that? Okay, great. So I hope you enjoyed the video, I hope you did the challenge, and I'll see you in the next one. Welcome back everyone to a brand new video. In this video we are going to be changing our player's state from our code. So as you can see right now, we have our player in the idling state as soon as we start the game, and if we move him left or right, you can see that his state changes into running, and if we stop, he changes back into the idling state. So let's not waste any more time and let's get started. Okay, so let's start off first of all by re-explaining what is happening in our animator. First off, we'll make it a bit bigger and zoom in. So first thing we'll need to take notice of is here in entry. From entry, we have a transition directly into idling. And what this means is that as soon as our game starts, we go directly into the idling animation. And from there, we have two options or two states to go to. We have the running state and we have the climbing state. And both have transition to and from. So for example, to go from idling into climbing, we can see that we have this white arrow line that has a condition on it. And that condition is for a boolean to be, a boolean called the climbing to be true. And in order to go back from the climbing state or animation, this climbing condition needs to be false. And the same holds true for running. So the transition from idling into running needs for a certain boolean to be true, and to go back from the running state we need a certain variable or parameter which is running to be false. So how are we going to do that using our code? Well, first of all, because the parameters are present on our animator, what we need to do is get a reference to our animator. So let's go into Visual Studio and try to do just that. So here we are in our Visual Studio. First thing we'll need is a reference to our animator, and we'll do that the same way we've done to get a reference to our rigid body. So let's go ahead and create a variable for our animator. So we'll create an animator, please. So an animator, we'll call this my animator, and we'll use the get component to get a reference to our animator. So get component animator, and close that up, save that. Great, so now we have a reference to our animator. Next thing we'll need to do, first we'll be focusing on the running. So how will we change from a idling, where is that? So from idling into running, how are we going to change that? Well, we'll have to set the boolean because we know that it is a boolean. Let's go back, and in running, when we start to run, let's go ahead and go into the running state. So we'll do that by using my animator, which is our reference dot, and it has multiple methods attached to it, and one of them is the set bool, and this allows us to send it a reference. Actually, it has two ways of giving it parameters. The second way is our way, which gives it a string and the boolean value that we want it to have. So the string reference name and the bool value, which can be either true or false. So let's do that. First thing, we'll need the string name, and because it's a string reference, we'll simply go back into Unity, double click and copy that reference. Because as we know, whenever we have a string reference, we always go and copy it. And now we need to set the value for it. And of course, it's going to be true. Now this is not the final solution by any means, but this will demonstrate how the set bool in my animator works. So let's go back into Unity and see if that worked. If we click on play right here, our player goes into the running animation. It's good, it's not bad, at least we know it's working, but this is not how we want it. We want it to go back to idling whenever we stop the running state. So that is going to be your challenge, and your challenge is to stop the running animation. So you'll need to add to our run method a way to stop the running animation, and that means going back to the idling. So it should stay true while the player is running and false when the player stops. Use the code we've created when flipping the sprite. So pause the video right now and go ahead and do the challenge. Okay, welcome back. So how did you get on with that? I hope it wasn't very hard, or I hope it was at least a bit challenging. So let's see what we need to do. Well, because I've told you we'll need to use something from the flip sprite method, we are going to check if our player is actually running. And we'll do that by simply copying the following line, which checks if our player has a velocity on the horizontal plane. So now we have a boolean for running horizontally, and what we can do, because this is actually a boolean and it's true whenever the player is running and false if the player is not running, we can directly set it right here in our animator. So we'll replace that with, running horizontally. And let's do one more step, and that is extracting this method into an outside one because it's just a bit different. We'll call this changing to running state. And now we save all of that. We have our changing to running state, which checks if our player is moving in the horizontal plane, and if he is, that means our running horizontally is true. That means our animator sets the running to true, and if he's not running, this running horizontally will be false, and hence our animator will set the running to false. So let's go ahead and see if that worked. Click on play. Our player is initially in the idling animation or state, and now if we move to the left, he starts his running. If we stop, he stops and goes back into idling. Great. So this is the foundation of controlling our animations from our code. We set up our state machine. We have parameters which we can access in our code when a particular thing happens. We can manipulate those parameters using our code and changing the player state. I hope you enjoyed the video, and I'll see you in the next one. Welcome back, my favorite game developers. In this video we are going to add the ability to our player to jump. So as you can see, he can now reach platforms that were unattainable before, and he can jump from one platform to the other, and as you can see, it's very snappy, it's very exciting, and it's going to be very fun. So let's not waste any more time and let's jump in and get started. Okay, so first I want to talk about the jumping mechanics and how they are. So the jumping mechanics will be a bit different than the running mechanics. Why is that? Well, because running is different than jumping. Because when we run, we actually pick up speed slowly, but when we jump, we technically immediately have a velocity upwards. So I just want to show you how our velocity actually increments. So if we print the player velocity to our console right now, let's go ahead and try that. As we start to run with our player, you can see that it's 0, 0. When we start running to the right, it increments slowly from 0 to 9.7, 9.8, and eventually to 10, and then goes back to 0, and the same goes when we click on the left arrow. But we don't want that in our game. We actually want our player to immediately jump as soon as we press the space bar or whatever button we would like it to be pressed, and we'll do that using a different kind of function than the get access. We'll be using the input.get button. So if you read the description right here, you can see that it returns true. So it's a boolean. It returns true during the frame the user pressed down the virtual button identified as button name. Anyways, what you need to take out of this is that it immediately turns something into true and then back to false if we pressed a button. And that's what we're going to use. And of course, instead of input, we'll be using cross-platform input manager, because as we've said before, we want this to be a multi-platform game. And let's jump in and get started with it. So first thing we'll do is we'll remove this print because it's done its job, it's finished its service. And we're going to create a function or a method right here, which we'll call simply jump. And now if we save that, we have the option to extract. We have this little light bulb on the left. Click on it and click on generate method. Don't worry about whatever is written already inside of it. It's a private void method, just as we want it. So what are we going to do? Well, first thing we're going to do is we're going to create a boolean, and that boolean is going to be called is jumping, and that is jumping is going to get an input from the cross-platform input manager, and we'll use the function that we just described, the get button down. So let's open it up, and we can see that it takes a string reference as an input. So let's go ahead and find the string reference of the jumping input. We go into project settings that is docked here on the right. So click on that, make this a bit bigger, and let's scroll down and see where we have the jump. There it is. So it's jump and its positive button is space. So let's copy this because it's a string reference, and as we've said before, whenever we have a string reference, we always go and copy it. So now we have the isJumping boolean set and ready. Next thing we need to do is we'll need to add velocity to our player in the y direction. So let's go ahead and do that. So we'll create an if condition, and if is jumping, that means if our player has pressed the jumping button, we'll create a vector2. We'll name this jump velocity, and this jump velocity will be equal to a new vector2, and in the x direction we'll only have my rigid body, so my rigid body 2d dot velocity dot x, and in the y direction we will want to add a speed for jumping, and this will be dependent on your preference. It could be 5, it could be 10, it could be 20, and whenever we have such a variable, well, when we have something that is variable, it's much better to create a variable for it, just as we did here below for the run speed. So let's go to the top and create a serialized field. And serialized field is something that we can adjust from different scripts. Maybe we won't need it right now, but let's just go ahead and make it a serialized field. So it's a float, and we're going to call it jump speed, and initially let's go ahead and make it 15f, because it's a float, so 15f, and let's add it to our jump velocity. Okay, great. And as a final step, we need to add this velocity, jump my rigid body dot velocity. Velocity is equal to our jump velocity. Okay, great. So save that. Let's go back into Unity and see if that worked. Make this a bit smaller, click on play, and now we move left and right, and if we press the space button we can see that we jump, but that jump is a bit floaty, as you can see, but at least it's a start. It's a huge leap forward in our game development journey. Get it? Leap forward. Okay, I will not make that joke again. So let's see what we can do in order to make this game a bit more snappy. So we can see here that we have a physics 2D option in our project settings, and what this allows us to do is it allows us to adjust the physics 2D of our Unity engine, and we have many options to adjust. We have maximum rotation speed, we have translation speed, we have angular correction, we have a lot of stuff in here. I will leave a link in the resources to go check out the physics 2D in the Unity documentation. You can go into every single detail that you want, but for now we're only interested in the gravity right here. And as you can see, our gravity currently in the x direction is 0, and in the y direction it's minus 9.81, which is exactly the same gravity that we have here on our planet. So if we click on play and we jump, we can actually adjust this right here. So if we make it, for example, minus 27, now if we jump, we don't jump as high as we did before. So this is where we begin to tune our jump depending on how high and how snappy we want our game to be. And a small reminder, whenever we finish adjusting something in our play mode, if we unclick from play, you can see that it goes back to its original value. So keep that in mind, because you need to remember the value that you chose when you were in play mode. And that takes us right into our challenge. And our challenge, or your challenge, is to adjust your jumping. So tune the gravity and jump speed to make the jumping mechanic to your taste, and base your tuning on how many tiles you want your player to be able to jump. So you can either make it 2 tiles, 3 tiles, You can make him the best and highest jumper in the entire world. It solely depends on your preference and how you want to make your game feel. So pause the video right now and go ahead and do the challenge. Okay, welcome back. I hope that wasn't too hard. I hope you enjoyed that type of challenge. So let's click on play and see what our player does. So we move left and right and we jump, and that jump is a bit too nauseating. So let's make this gravity 100, and now it's a bit more snappy. And in order to help our player jump higher, let's click on player, go to its inspector, and let's make the jump speed, I think 50. So let's see, 50. Now our player jumps and you can see that he actually disappears below the platform, which is not good. And we faced this problem before, as you can remember from, I think it was when we added the run speed to him. So we need to fix that before we continue. I don't know if you faced this kind of problem while doing the challenge. I hope you didn't, and it's not very hard actually. If we go into our player's rigid body, you can see right here that we have something called collision detection, and it's currently on discrete. And if we click on the list, we can see that we have another option which is continuous, and this is what we're going to choose for our player. Now what does that mean? Well, discrete is it checks for collisions every certain amount of time, while continuous is, as it says, it's continuously checking for collision every, I think, microsecond or millisecond, I'm not sure. But discrete is, for example, every 1 or 2 seconds it checks for a collision, and the continuous checks constantly for collisions. Now, why do we have the discrete option? Because we might not have a body that is very fast, so for example a slow moving bird or something that will not need a continuous collision with things around it. But if we have something like our player, for example, right here, that has a gravity that is 100, he falls right through our world. So we'll make it continuous. Continuous is a bit more heavy on the processor of Unity, but it's okay, we can handle that, I'm sure. So click on apply, go back into projects. Let's make this gravity 200, because I think we'll need it to be 200. Let's make the jump speed 50. Save that, go back into play mode and see if that feels nice. It does feel nice. So let's see, I think it might need the snappiness to the ground. I think the gravity is perfect. Let's see if we want to make, I think that's enough. I think 50 for a jump speed is perfect. So I hope you tuned it to your preference. You don't have to make it just like me. You can have it whatever you want. It's your game, it's your preferences, and I'll see you in the next video. Tony Robbins once said, if you want to be successful, find someone who has achieved the results you want, copy what they do, and you will achieve the same results. I would love to teach you all about game development, and the best way to learn anything is by doing it in a fun way. Using Unity's engine 2D, we are going to build our 2D platformer. My name is Michael Moore, founder of M Game Dev, and my goal is to make you the best game developer in the most fun way possible. I've developed a strategy that has helped thousands of aspiring game developers achieve their goals of creating real-world games, and I want to do the same for you. What I've learned is that it can be very difficult to know where to start and what steps to take to go from beginner to intermediate to professional, not only in game development, but in programming and learning how to code. And I can say with absolute confidence, this course makes it easy for any beginner with zero coding experience to jump in and start learning how to create incredible games. And the most amazing part is that we're doing all of this with the latest version of Unity, with the newest techniques and content in modern game development. I've helped thousands of people create real-world games, and I want you to be one of those people. So, how are we going to do this? First, we are going to build the foundation by learning the fundamental aspects of C# programming. We'll understand what variables are, how to do if statements, and create our own methods and functions, enabling us to make incredible games. And while you're building confidence in those areas, we are going to be playing in Unity's engine. You'll understand how the interface works, how you can easily add game objects and get comfortable with everything available to you in Unity. And the third component and most important one is the game design side of things, where we'll talk about player experience and create something enjoyable for anyone looking to play your game. We'll then move on to more advanced C# that will enable us to control our game and everything in it in a much better way, while still keeping our code readable and very easy to understand. We'll then delve deeper into Unity's tools that will allow you to enhance your player's experience, enhance your learning, and expand the horizon of the games that you can make. And we'll create a synergy between C# programming, Unity's engine, and game design, and from it build an incredible and fun game. So, what should you expect by the end of this course? You'll become a master problem solver. You'll understand the fundamentals of coding and learn how to program games just like the ones you're seeing on the screen right now. You'll also have the chance to flex your game developer muscles, because with every video there is a mini challenge for you to complete. And even if you can't figure out how to do the challenge, don't worry, I will be there to help you after you've tried and complete the challenge with you. Everything in our game will be configurable, so you can tweak, play around, and give the game an individual and special feel about it. So you will be putting your own creativity into it and really making it your own. I'm so excited to get started and hope you are too. This is the perfect time to start learning how to code, so dive in with me and I will help you along every single step of your game development journey.